participants, good morning. Today we will take the lessons from Stephen Samuel sir. Yesterday he talked about load balancing as well as scaling. He has explained different types of load balancing. Suppose application load balancing, network load balancing, gateway load balancing, and the last one that was a combination of application load balancing and network load balancing. So that day, yesterday, he demonstrated us how an application load balancing works within a VPC. Now today he will explore. He will go deep dive into this load balancing. He will share how an auto scaling works. Okay, because the major function of load balancing is to distribute the load among the servers and to check the health status of each and every server. So, but say suppose if there is a need to make provision of a new server, or we have to make a deprovision of existing server. So in that case, load balancing does not work. So in order to work it, auto scaling comes into the picture. So we all, I think, have understood that there are two functions of load balancing: to distribute the load among the servers and to check the health status of each and every servers. But the load balancer cannot add or remove any server from the target group or from the target group. So it is the work of auto scaling. So now Stephen sir will explore about auto scaling. So Stephen sir.
Yes. Good morning, everyone. Thank you, Naveen.
Okay.
So we are looking at load balancers, auto scaling, and then we look at something very interesting also. This is dynamically allocating workloads on AWS, but using elastic load balancers and the auto scaling groups in together. So that's a very powerful tool that we can use. We get the benefits of both. So we'll both, of course, bring their benefits. Autoscaling, by now, I guess, just by the name, you understand what autoscaling can do. That it will scale your application either up or down, depending on traffic, the number of requests to your websites. Also, not only that, but autoscaling also means that according to your configuration, actually, it's a template or launch template. According to your launch template or specifications or your launch configuration, you may always you are guaranteed to have enough instances servicing your website, because if an instance goes down, AWS will automatically create it for you. That's so of course there will be some downtime, but we're talking about minutes, just minutes. On our machines, it will take maybe less than 5 or so. So let us see first. Let's look at one of the most popular load balancers. That's the application load balancers. So we saw a number yesterday. There's a couple of things we should take a look at. We have just one slide actually to discuss. I wanted to talk to you all about cross-zone load balancing. Okay, what is that? But before we do that, yesterday we on the topic of load listeners, And this is basically, it's a conditional logic that you can actually program, not program, configure as such. Now, associated with that, whenever we are dealing with load balancers and auto scaling, we have to actually, health checks are critical, very important. So you have to pay when you're configuring, when you're creating your auto scaling group or your load balancers, you have to pay particular attention to your health checks. Now, the Elastic Load Balancer will associate a health check that is performed against the resources defined within the target group, which are basically your servers, your EC2 instances. So these health checks, they allow the ELB to contact each target using like a specific protocol to receive a response. So if no response is received within set thresholds, then the ELB will mark the target as unhealthy. It will stop sending traffic to this target, and eventually it will start registering the target and removing it. Okay, now you have seen that ELBs are of two types when we were configuring them. When we were creating our first ELB yesterday, we were doing a classic ELB. But today we look at the application ELB. Those are the most used ones. So we have this internal and internet facing ELBs. So these are actually two different schemes that can be used for our load balancers. So internet facing, as the name implies, the nodes of an ELB that are defined as internet facing are accessible via the internet. So obviously they have a public DNS name, and that can be resolved to a public IP address. Like on our screens, you remember that um, we have, whenever we are connecting, in any case, we were testing out an Apache web server, we'll copy the DNS. Actually, both will work. So we would copy the DNS name and we paste it in our browser. But it'll also work if you copy your public IP. Generally, we copy a DNS name, but it's always public. It's something like EC2-server 1023, etc. That long string. Now, an internal ELB only has an internal IP address. This means it can only serve requests that originate from within our VPC itself. For instance, we might have an internal load balancer which is sitting between, say, two web servers in a public subnet. And your application servers would be in a private subnet. That is there. So many different configuration scenarios are possible. Now, you remember that during the creation process of our ELBs, we were required to define which availability zone the ELB would operate. So for each availability zone that was selected, for instance, here we have two, A and C. So for each one that was selected, so an ELB node will be placed within that availability zone. Okay, this actually is our ELB. This where my mouse is, which circle pointed to by the blue arrow. So as a result, we need to ensure that we have an ELB node associated to E- obviously an availability zone for which we want to route traffic to. So without the AZ associated, then the ELB will not be able to route traffic to any targets within the AZ, even if they are defined within the target group. Because it's the nodes which are used by the ELB to distribute target to our traffic to our target groups. So when we were setting up, that's why we had to be very careful that we had our availability zones associated with the ELB. Otherwise, it won't make sense. Now about this cross-zone load balancing. The last thing we need to this. Just take a look at this representative picture. We got two availability zones over here, both on the left and the right. Okay. So actually, this also depends what kind of ELB option we select. We have the option of cross-zone load balancing within our environment. So let's take this example. We have two availability zones activated for our ELB with each associated load balancer receiving equal amounts of traffic. All right. So as you can see on the left, we have one AZ has 6 targets and the other has 4. Now, when cross-zone load balancing is actually disabled, each ELB and its associated availability zone will distribute its traffic with the targets within that AZ only, which makes sense. That is actually the default setup. So you have these two ELBs, two availability zones, what their disparate numbers of instances or servers in each. So when you have it disabled cross-zone load balancing, it just follows its default behavior. Whatever traffic comes in, it will be distributed with the targets within that availability zone itself. So as we can see, this actually results in a very uneven distribution of traffic for each target across the availability zones. So with cross-zone load balancing enabled, regardless of how many targets are in an associated AZ, the ELBs will distribute all incoming traffic evenly between all targets, ensuring that each target across the AZs have an even distribution. So this is what cross-zone load balancing does for you. This is what that option is all about, which we have for most ELBs, I think. Okay, so what we will do, let us look at an application load balancer. We should take a look at that. That is the most popular load balancer as of now. So let us create our first application load balancer. So just like before we actually start, we should make a note of your region also. So we should decide we will need two availability zones we'll be using for our EC2 instances. Along with this, we'll need our virtual private cloud, our VPC. But don't worry, it won't be like we're not going to make it from scratch. Yesterday was just to drill down into the details of creating a VPC from scratch. But for now, we will take our default options. So our virtual private cloud, we will configure with at least one public subnet in each of these availability zones. Yesterday, when we did uh, created a virtual private cloud, we did a very extended version of it. We also had subnets. We had one public and we had both. We had both private and public subnets. Hmm. Over here, by the default, VPC actually comes with simply public subnets. That's what we'll be using. So the public subnets are basically what we use to configure our load balancer. Okay. Then, of course, in each zone, we will launch one EC2 instance. And what we'll do also, we'll enable it to serve up a web page. Now, just like for connections, we need the port open, which is 22. For this, we'll need to allow HTTP access on our port 80. Okay, so let us go to so just log in and open up to your region, or you can select a brand new region also. If you over there you won't have anything set up. So I suggest you take one of the top 4. If you already got stuff running, you can select one of the top 4. So let's see, I have 4 instances running. I got no load balancers. Okay, think this region is fine for this. And then we open up load balancers. All right, so everyone with me so far? And then we click on create a load balancer. And this is what we've been discussing. We have 4 types. We have an application load balancer, a network load balancer, and a gateway load balancer. And also a classic load balancer, which runs on the EC2 classic network. All right. Let's create our application load balancer. So over here, we just need to enter in a name. Let's see. So this will be this you can simply leave as a default. Now, Naveen, you were talking about listers yesterday. This is actually the listers you were intending. But the
Yes, sir.
listers there's also the other type which has these conditional rules and the logic as we saw previously on the slides. That's what that is for now routing, actually.
Yes. Yes, sir. Yes, sir.
Anyway, we're not getting into listeners. That is, there's so many options for configuration, really. So anyway, listeners, we'll just keep the default. This is basically just a listener that accepts HTTP traffic on port 80. That is fine.
That's the thing.
Okay.
Simply, I told you, sir. Simply, for the simple understanding, listener is
Ah,
simply a port. We just define a port to listen in which source the traffic is coming, like that.
yeah, that's there.
Yes.
For VPC, we have just you can we can simply take the default, okay, and select the first two. Now there's something we can do. Just click over here. I don't think there's any issue if we actually have two tabs open, right? So I'm going to make a note of this because we it's too easy to get confused. So this is my VPC and these are my availability zones. I need to I need to make note of my subnet masks as well. So you see, I need this is my availability zone. This is my subnet. These two things are pieces of information I need. So in those, I am going to create my instances. So let me come over here. I'll go to instances. I'll go to launch instances. Okay, I could select our usual free tier eligibility. This you just remember for future use. The family is T2 and the type is T2 micro. That is what we generally need. So here we have this. Now, this is why just make a note of that. Just a second. Okay, so we could choose initially our VPC is the default. That's fine. The first is US East. US East to A. Okay, so that we'll create our first instance over there. Everything else will remain the same. Our storage, we take our defaults. Just add a tag for so you can identify our instances actually. Let's create a new security group. Now this security group, as usual, it should, if we want to connect to it, we must always allow SSH. Actually, we need the more also besides that, we need a public address. So if we don't have a public DNS address, then it's not going to work, of course. It's still possible, but with somebody like more or less complex configuration. So we'll create a rule over here, and that is just HTTP, and this is good enough. There's nothing really else, anything else we need. So here's our new security group. Now we can review and we can launch this. So let's go ahead and just the same way, let's create another instance. Same way. Now here's our default VPC. I believe this should be 2B. 2B. That's fine. Then we are going to add our storage. We'll add our tags. Our security group is over here. So this is our permissions. Okay, so all set. We can filter instances also, by the way. Let's see, we have instance state. Oh, okay. So now you see, now we have two instances. We just didn't go and go whack, 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 like how we normally do. We have to make sure that our instances are in the same availability zone as our load balancer. In other words, like whatever availability zones our load balancer spans. So we have to keep instances in there. All right. So we have this over here. Now we can anyway, let's carry on. Let's configure our security settings. So for our security settings, let us take our existing security group. Don't take the default. Let us take what we created, which is IALBSG. Okay. Then we can configure our routing. Now, this is a little bit new, maybe. This security group for our load balancer has to allow it to communicate with registered targets on both the listener port and the health check port. This is where this is our HTTP protocol. Okay. So we have our targets, which are instances. This the load balancer must be allowed to communicate with our registered instances on both the listener port and the health check port. So the Okay, and now about the security group. Let me just see. Just a sec. This one is okay, but the fact is that this default security group, Amazon Web Services, intelligent enough to look at your what you have set up, and then it will provide the appropriate create a security group with the appropriate permissions. But this is fine. There's nothing else we need. Okay. So here we come back to our listeners again. Enter in a name for this. The target type will of course be instance. The default rule for our listener actually routes requests to the registered targets in this target group. So the load balancer checks the health of targets in this target group using all these health check settings defined for this target group. Right. So all the requests go to the listener and they go to all the whatever instances are registered. Actually, the target can be different types. For us as instance. Generally, that's it. And this load balancer also checks the health of targets using this is the protocol, and the path, as you can see, is just slash the root of your directory in any case. The root of your web application. That's where it goes. And these are your advanced health check settings. You can see it happens at every 30 seconds for this. This is your timeout. I find these are a bit on the low side, actually. But if there's so in my failure instances, because I find it a bit on the low side. It could be network bandwidth or whatever. But if there's a problem, we'll always edit. We can edit these settings after creation. That is not a big deal. So we just keep the default target type as instance, the protocol as HTTP, one HTTP really, port as 80, that's all. Now we need to actually register our targets. So for instances, let us just take a look. Here's our two instances we have created. Okay, so let's do our instances. We got the default port keep as 80, and we simply say add to registered. Hmm. This is from our security group. Okay, so here's our instances and internet facing scheme. Here's our security group which we had created, our target group name. That's it. Very straightforward, more or less. Okay, so now on this review page, we can simply create our load balancer, and its provisioning stuff. Now come down over here in your left navigation pane. There's a target groups over here. Just select that. Okay, so our target registration is actually in progress. So what this basically means, like if the status is initial, which is our health status, it's still obviously like it's in the process of being registered. Or it has not passed the minimum number of health checks to be considered healthy. Our health checks won't show us much over here. It is just going to show us our settings. Actually, our targets, this our health status is over here. No, so once the status actually turns to healthy, why does this happen now? We need at least one to be healthy before. Very strange. I find these on the low side. I'm gone over here and I'm going to edit health check settings. So the response time is only, that also is very strange. It's if you're having a problem with it, then go and change it. Override your health check settings because it's on the low side. And depending on bandwidth and stuff, like for instance, over here, the checks have passed, as we can see. I've run into this issue before. This is nothing new. Our status checks as well, you can see the checks have passed. So it is something to do with our health check settings. So if in a case like this,
Sir, Steven sir, if we reduce
huh?
the healthy threshold values, so it will, I think it will take less time to be sure that our target groups are healthy. Healthy threshold, sir. Healthy
Right, but it's
threshold.
not giving our instance enough time to respond, maybe.
Yes, yes, yes.
Because I come across this before. So I've been forced to edit these health check settings, and
Okay,
then it passes the health checks. That's what
okay.
I've been forced to do very often. Let us see. So if you're having this, then go ahead and do that. So anyway, I've deregistered and I registered it again. Take your first instance. Let's connect to it now. And we'll go to command prompt. Okay. So you remember what we're doing? We're simply copying this from here. And then we go, I'm in the same directory where my PM is. All right. So initially just, we're going to set up our Apache web server on this. Uh, so run that update first. Then you can, it asks you this, just put yes. Okay, so now what we got to do is we have to basically, we install our Apache web server now. But before that, if you remember, we have to install PHP. So we go to its sudo, then Amazon Linux, dash extras, and then install. This is the LAMP stack, by the way, LAMP, and we're using MariaDB database. MariaDB 10.2-PHP. And then repeated with PHP 7.2. Okay, so this is how it will look. So what this does is this is the PHP software using this Amazon Linux extras install command. So what this command does, it installs like multiple software packages, as you can see, or about to see, and related dependencies at the same time. So let's check once is sudo Amazon Linux extras install dash flag y lamp MariaDB 10.2 dot dash PHP 7. Okay, that's fine, I think. No, MariaDB not found. This is what we always use. How come? Oh, okay. There's a space over here. There's a space. Just remove that space over here. Now it's okay. Now let's install our Apache web server. Sudo system. Oh boy. Sudo. Now we get started. So we have a public domain name here. Instances. So I need this. So just copy and paste it. We should see something. This is what we expect to see. All right. Now in your just a second, I had left some in supporting materials. I had actually left that. Just open that supporting materials. This should work. Let us see.
Sir, maybe sudo, sir.
Oh no, this won't work. There's a, I had to actually, it's there. Very much it's over there. One sec.
I'm, sir, telling we use echo, sudo with echo, sir.
Yeah, this exactly. Actually, it's sudo with chmod.
Yes, yes, yes.
This is, I had set it up. I left it for y'all already. So we just want to build a simple index.html. Where is this date two? Oh, it's in your date two folder. There's a web server commands. Open that folder. It's in your date two folder. We are meant to do that. So it's over here. Open that and you'll have that. What we have to do is we have to chmod over to it because I don't, you see this varw HTML is actually a publicly accessible directory. Supposed to be. It's supposed to serve up on your Apache web server. This is publicly accessible. It's just supposed to serve a static file. That's such. That's what it's used for, which we are going to do. So I don't know why it's makes such a hassle about denying permission. So we have to explicitly set permissions here. You can just copy paste it and then put some message, whatever you like. There's a number of ways we can create this actually, whether we use sudo or anything else also. Now we can cd over to that directory. We can list it. And of course we can cat it. In other words, let's see what it's got. Okay. So that's that. And there we have, actually I want to do this because we need it for our load balancer. This is why I'm doing this. I want you all to do this, then we'll know the load balancer is serving which page from where. So that's why, that's the reason for this exercise. Anyway, it's always good to set up a web server and do something with our instances instead of just letting it lie there. Okay, so we've done that for this. Let's please do that for instance 2 as well. So instance 2, let's connect that. Okay, so we simply quickly okay, so we have to put in all this. You might have to do this a number of times. You could actually make a copy of your commands and put it in a notepad like this, because we use this frequently. Okay, now we've done that. Now we have to install PHP, of course, right? That update is always has to be done. So once again, sudo I think I'll just put this up on the GitHub website because this copying pasting this for getting into a typing exercise as such. Anyway, we have sudo amazon dash linux dash extras install dash y, then the lamp stack we install. Lamp Maria db dash no 10.2. So my target registration is in progress and you see it's healthy. So you see, I don't believe that default settings on Amazon are correct. I mean, they're correct. They're at a very low end. We're not giving our instance time to respond. If you ping it, ping, and then you expect it doesn't respond in that time, and you say it's unhealthy, it doesn't make sense. So that's why if anyone else is having this issue, I've run into this before. It's familiar to me. If anyone else is having this issue, then you could do the same thing. Go to your we will have to change it over here. Okay. Already in target groups. Here's our load balancers. Target groups. One sec. Go to health checks. And then come to edit. So I would advise you all to override it if anyone's having this issue, because I've seen this. Is anyone having this issue actually? Sorry, Dr. Prasad, what do you mean fail to connect to default zones? I didn't get you. Oh, if you're, oh, all right. Sorry, I didn't see your message. That's fine. Anyway, anyone else is having this issue, let me know. Naveen, you're fine.
Fine, sir, fine. Happy to
So
see.
your targets have come up healthy?
Yes, sir. Yes, sir.
Very good. Very good. But I, anyway, just for your information, if that is ever happens to you all, then just, you know, edit your target settings. Give me a second. Let me just, I'll put this up later so we don't have this typing exercise every time. And now we simply need to go ahead and install Apache. We actually want you all to have a web server on each. So then so we can test something. Load balancing basically means what? That it'll switch the load. Now we need some way of knowing what's happening. So that's why we're doing all this. Sudo yum, right? My typing skills are not the best today. All right. So sudo yum, here's a server. And over here, it's simply start. So we start. Okay. So now we are over here. Let us simply go back to our instances. This was this one. Copy DNS instance. If we simply paste it in, it should be okay. That's what we expect to see. As a matter of fact, now we should do this. So do the same thing, please. You have to chmod over to this. This is your Apache web server directory. So why it complains, frankly, I am not sure. Because it's supposed to be publicly accessible. So finally, I just put the permissions down on this. And then welcome to something, whatever you want, web server 2. Put whatever you like. You could put welcome and hello, whatever you want. Let's see that that was done properly. Okay. So now if we simply go back and refresh our page, now we know that we have an index.html on this as well. Okay, so let us go back to our load balancer now. It's taking ages to register it. Anyway, we can test it. Let's go ahead and test it. Oh, it's come finally. So you see, it's not my imagination. I am telling you something is very strange. It's not happening with you all. Maybe your bandwidth might be better or whatever. Something. Something. But otherwise, it's so weird. It's so weird, actually. So our health status is okay. That's anyway. So remember what our target groups are very important because we'll need them for both our load balancer as well as when we are actually doing our auto scaling. Right. So now we've got this in place. We got this in place, and instances are running fine. We've registered our targets properly. Is there anything else? Just give me a second. I think that's it. So we basically bound our targets with our target group. That of course is absolutely necessary. And our instances have come out to be healthy as well. So, okay. You need actually at least one instance, to be healthy. Only then you can choose, only then you can actually test it. So we have a description tab over here. All right, we go back to our load balancers. Yeah, just treat it just like an instance. You have your AR and don't make the mistake of copying that. Copy this DNS. Okay, and then you just copy your DNS name. Just copy pasting it in over there should work. There we go. So what is deployed? Your load balancer, remember, is simply it actually balances the request. It's a router. In the end, it's a traffic policeman. Depending on the requests that come in, it wants to allocate the request between different what you call the servers. And now this it does in a fashion like this. So can you see it changing? Remember our discussion yesterday? The load balancers which are set up by Amazon Web Services, they dispense traffic to our different EC2 instances in a round robin fashion. That was our slide, the first slide that we were looking at. So it dispenses it. Just let's take a look at it actually. No harm in that. So this is actually what we were talking about. Traffic will get distributed between two availability zones in a round robin fashion. So first it'll go to our server 1, then it goes to our server 2. So this is why I want you all to actually create all this stuff, set up everything, set up your Apache web server, and have at least, we don't want to see our default test page. So something should be over there that we can see, we know which server it has gone to. So that's why we have server 1, and now we got like server 2. So you can see it's not random also, it's round robin. It goes first to server 1, then server 2, and back again, and so forth. That's how it is. Now within the available, that's not all though. Within the, this is just to balance it out as evenly as possible. So in other words, not only balance across availability zones, but also balance within availability zones. So that's the reason for this strategy. You send requests in a round robin fashion to your availability zones. And then within the availability zone, you dispatch a request to the instance with the least number of open connections. So this is how it goes. Okay, so it's much better when you actually see it happening in front of you, right? Then it sort of you can connect. It connects then. Okay, so that was our application load balancer. Now, what we should do now, let us create an auto scaling group. We are going to reuse this, okay? So I don't want you all to do useless work. We are going to actually reuse our load balancer later on, hopefully today. I believe Mr. Charan, who you all may know, the CEO of ByteXL, he will be taking the last session of the day. So I am taking the first two, and then you'll have a guest speaker for the third part. But I guess Naveen has informed you all already. What we are going to do now is about auto scaling. We are going to create an auto scaling group. Okay. There's nothing much. You'll notice that the slides have got less every day. That's because uh, all our stuff is actually mostly hands-on nowadays. We're going to get into the actual implementation portion. As I said, the first day is a little heavy because we have setting up a conceptual understanding, our foundation actually for the rest of the week. So the first day is very theory oriented, but not after that. All right. So what we are actually looking at over here, it's about EC2 auto scaling. So let's start this, and then later, while the instances are being created and all that good stuff is happening, we can always discuss, a little bit more in depth on auto scaling, how it actually works, and the implications of it, and the settings of it all. So with EC2 auto scaling, so anyway, if you can work on a number of things, as you can see, like me doing. I'm doing my instances in one tab. Amazon doesn't mind. It won't log you out if you open a second one. So you can work like that also. You can create your instances and, in one tab, and all our main work we can, you know, creating our auto scaling groups, etc. we can do in the first tab. So when we're using Amazon EC2 auto scaling, basically we must use certain building blocks to get started. Now this we are going to go through the process of setting up the building blocks to create like a basic structure for Amazon EC2 autoscaling. We are going to use a group. All right. Now, first we have to think some things through. One is how many availability zones this I hope everyone saw what I was doing. I went right down to autoscaling and there's a autoscaling group over there. Okay. It's like how many availability zones the autoscaling should span. Now, what existing resources also can be used, like Amazon machine images or security groups, whether we want to scale to increase or decrease capacity. Or in our case, we simply want to ensure a specific number of servers are always running. That's all. That's all we are going to do. Then as far as metrics are concerned, like what metrics have the most relevance to our application performance? How long is it going to take to actually launch and configure it? Okay, so it's like, the better we understand our application, the more effective we can make our ASG architecture. So we can, before we actually get into creating an autoscaling group, let us actually we need to do a launch configuration initially. So just click on launch configuration. I'm actually wondering whether we should create a launch configuration or a launch uh, template. Just a second. Mhm. You see, the launch template is pretty decent. Here's our launch templates. Actually, let's get out of this. Otherwise, we'll have too many tabs open. So on the left navigation pane, we have a launch template. Let's select that. It's new, so I want you all to see this one. And it works fine. It's actually pretty good. But occasionally, there's two things. One is like a pay as you go kind of a thing. Don't ever select that because then you'll be charged. And if the other option is like use the auto scaling that is specified in the template. If it ever happens to be grayed out, then cancel and do it again because it happens. Okay. So we can put this as ASG.LT. Auto scaling group. Yeah, that's right. You put any kind of name that you expect. We can select this checkbox. That is fine. This is relatively new also. we can choose this. Okay. And you try and remember this. This is T2 micro. Okay. This is for us on our free tier. So take a version of, take the first one. I believe that's all right. Take the first one. So now this Amazon machine image, we can also create our own, remember. Now here's the thing. In this this particular case, it's not a load balancer, it's an auto scaling group. So I don't actually need to actually access the internet or my root web directory. So I don't need Apache web server. But if you need a web server, then suppose we have our instances already created with our web server. If we create our image from one of those instances that we did just before, and then we select it over here, all right, then what will be deployed is that a machine image with all our configuration and our software installed, everything. Now our instance type, remember this one, okay? It's T2 micro, that is ours. All right, so select that one. Our key pair, just a second. I want to check something. Okay. You can take, actually, you know what? It's not overwriting, by the way. For your key pair, when you see, I'm always selecting the same one. You can do the same. It's who wants to, you don't need to create over and over a million key pairs. Nothing like that. And it's not overwriting it. Whatever is the key pair value that is generated for your particular instance or anything that you have created on your console, that is added to that key pair, it seems. So no issues over there. Don't worry about that. Anyway, leave the networking platform. We'll just leave it set to VPC. Our security group, we can take our alb.sg because it's open to, it hardly matters. Yeah, it has to be in the same VPC, virtual private cloud. No, this is necessary. There's two conditions. One is our security must be in the same. We are using the default VPC. So that is alb.sg. All right, that's fine. Now, the security group has to be in the same virtual private cloud that you plan to use as the virtual private cloud for our auto scaling group. If you don't specify a security group, what will happen is that our instance is automatically associated with the default security group for this VPC, which is actually fine. That is also, basically it needs to allow access over port 80. That is also there. The networking interfaces we can leave empty. Our advanced details, Just as a matter of note, you know what you can do over here? You can transform this into a set of instructions. You can put it over here very often. That's one way. And then once it runs, whatever instance it creates, suppose I have to rewrite this, obviously. Whatever, uh, however it runs, once the instance like this is created, and then it will create a web server for you. You have to put it in this field. So, so this is, it's a little misleading. It's not actually user data. You are not specifying environment values or name value pairs. This user data is there to configure an instance or run a configuration script during launch. Okay, so once it's launched, it will run a configuration script. So realistically, I can do these. I can put in these commands and there's no need for these two last ones. It's possible, and then we can actually run all this also. So that's pretty neat. All you'll have to do is copy a script and your Apache web server will be created automatically. There's nothing else you will be needing to do. Now we can simply create our launch template. Oh, okay, so we have a break now. Let us then I'll see you all at, is it? I'll see you all at 11 o'clock. Is that correct, Navin?
Yes, sir. 11 o'clock, sir.
Okay, so go ahead, please, and we will continue. So now then we'll continue. We'll set up our auto scaling group, and then we'll do a slightly more complex variant where we'll be actually dynamically allocating workloads on Amazon AWS using both elastic load balancers as well as the auto scaling group. And what we've done, we'll review. So we won't be doing any unnecessary work. Don't worry about that. Okay. Okay, then I'll see you all in at 11.
Sir, it's me, Naveen. That will be more interesting if you will go deep
Yes,
dive
it will
into
be.
that.
It's very powerful because you get both advantages, both features at one time.
Yes, sir. Yes, sir. Because
Auto
we have
scaling as well as load balancing. So this is where we, you know, we're talking about uptime. This is now where we can get it to real fault tolerance.
yes,
It's
sir.
high availability, but fault tolerance is on another level. So this is as close as we can get to having a highly available and fault tolerant web application. So it's interesting.
Or
Okay.
we can say that full-fledged fault tolerance, like that.
Yes, exactly. Exactly. Okay, then I will see you all later. Hello, everyone. So we are,
Hello, sir.
yes, we've just finished creating our launch template, and you can click on show templates. It'll show you all the, it'll show you all the details. You have one launch template by now. Fine. So this is a Amazon machine ID, Amazon provided. Our instance type is over there. Okay. Now we can go and actually create our auto scaling group. We are going to use a single instance auto scaling group. So we can come down over here to auto scaling group in your left navigation pane, create an auto scaling group. Give it some name. This is our first actually. And it's got conveniently, it's got like all these steps for us to, we have to follow the process. So that's very convenient also. So our launch template, let us see. Here's our asg.lt. I'm making a record of all this because we're going to need it later on. So we can't get confused about what our availability zones are and what launch template we use and all the other settings. Otherwise, we'll be hunting through all these auto-generated IDs just to find what we did. Okay, so that's that. Now we can there. Now this we just put adhere to launch template and disregard this completely. Sometimes some things get a little bit like screwy on your console, and this sometimes might be grayed out. Don't choose this. If it's grayed out and you can't accept it, then it's going to give you a lot of purchase options and ask you to buy for this, that, and the other. Don't do it. So adhere to launch template means that whatever you specified in your launch template, that is exactly what is going to be configured. Okay. So what does it mean? It means that in our launch template, what have we actually done? We've chosen an Amazon machine image. And that was basically it. So it's going to run one instance, right? Okay, so we adhere to the launch template. Now here's our default VPC over here. And that is fine for us. We are not going to get into it like yesterday where we created from scratch. This is actually, it'll create a couple of public subnets for us. That is okay. So the network will be our default VPC for our region. Our region, mine right now is Ohio at the moment. Okay. And as a matter of fact, if you find your stuff getting a little bit too cluttered, you might just, you have the option of, you know, you have the option of changing changing your region, and then it'll be complete. Nothing will be set up depending on, you know, if you switch your region to something else, California or whatever, Carolina or whatever. All right, so for the subnets, we have to choose from our availability zones. So we can take this, we can take the first one, the second. We can take all three, frankly. Now, when we choose a subnet from multiple, when we choose subnets in multiple availability zones, this is what contributes to a high availability. So there's actually three over here. At least take two. East 2A, 2B. Okay. All right. Over here, it just keeps the rest of the defaults. Later, we'll do the second option, but for now, we just keep the defaults. We don't need this. We don't have an attached ELB over here. Fine. Anyway, just take a look at this page. We'll be looking into it in more detail later. For now, just accept the defaults for the rest of this. Now we have this group size. What this actually is the size of the autoscaling group that we have. Here's our desired capacity, a minimum or maximum. Okay, our scaling policies, just leave it as none. This means that I want at least one instance at all times deployed, at least one. And you'll see shortly what that actually, the implications of that, what that actually means. You can skip the notifications tag, and we just put name. ASG1, it's fine. Put as ASG only, whatever. Put in anything that will remember. Now simply go to the review page. So we have our autoscaling group name, our first ASG. This will adhere to the launch template. This is very important. We have a default VPC, our virtual private cloud. We have 3 subnets and 3 availability zones. We don't have any load balancing, not now. The health check type is simply on our instances. Later, we'll enable it for our ELB, our elastic load balancer. For our group size, we have said we want a minimum of 1 instance deployed at all times. We don't have any scaling policy in place, no need. No for the protection, scaling protection, no notifications, tags are over there. Now we can create our auto scaling group. And as you can see, it's provisioning. Actually, okay, updating capacity. Now let us verify that the group has actually launched an EC2 instance. So we got this is already an auto scaling groups at the moment. Okay. The details tab, of course, will just show all this. Here's our maximum capacity that we've given, minimum, this, that, and the other. All right. Now go to the second tab. This is where we get all the good stuff. There. So read this and we see this will update. Amazon will update this. This is for auto scaling groups. This is actually our main page. So Amazon will automatically, this activity history will automatically be updated depending on new requests or what is actually happening. So what happens over here, it'll show, this actually just shows a current status of our instance. So it's already launched. Okay. Sometimes it shows pre in service. If it's taking time, it'll show pre in service if it's taking time. And then once it's after the instance is launched, then it actually shows successful. Otherwise, you can also hit the refresh button as Naveen advised yesterday. That also will work. Manually hit the refresh button and see whether the status changes. On the instance, let's go take a look at the instance management tab. Now here's our instance. Okay, it does take a short time for the instance to launch. Here's our instance ID, and it's saying that it's in service. The status, thankfully, is healthy. Thankfully, this all is not exactly what we're going to look at now. A little more, advanced metrics and stuff over here. So the main thing is actually our instances. We need to look at this part. So here's our instance ID. We've got it's in service. This, remember, is our storage T2 micro, which belongs to our free tier. Our launch template configuration, the health status is simply healthy. Availability zone is over here. Okay. Okay. So now we've got this. Now what do we do? How do we even know it's actually working? Okay, so just to learn how autoscaling actually works, what is autoscaling? Autoscaling actually means that it'll scale to meet demand and it scale up and down. What that brass tacks, what are we actually talking about? It means if the number of request traffic to your web application increases, it'll create more instances to service it. And if it's not peak period, peak hours, then it will scale back. It will drop some instances. It will terminate them. That's auto scaling, and it knows what instances you have. You've set everything up already. Great. So now what we need to do is we have said we have only one instance. Now here's another thing. Suppose that it makes these health checks, right? As you can see, it comes across a situation where it finds that the status of an instance is unhealthy. What does that mean? It cannot connect to it. It's trying to connect to it, it's trying to talk to it, but no response. In that case, it is marked it as unhealthy. It'll remove it from service. And it'll create a new service and replace it. So what are we going to do now? The minimum size that we created. Okay, firstly, autoscaling means that it launches new instances when necessary, and not only that, removes them when necessary also. So scale up and down. So the minimum size that we have created is one instance. I specifically asked you all to do just one instance for this reason. So if we terminate the running instance, Amazon EC2 autoscaling must launch a new instance to replace it. So now here we are. We have this over here. Just go to your instance ID and select it. It's opening a new page. Okay, great. Here it is. We don't have any tags on this, huh? All right. So now this is the instance that is associated. Remember, this is created from an Amazon machine image, Amazon provided machine image. All right. So now that we have the instances page, this is basically the instances page, right? So now that that's open, we can go to instance state over here and choose terminate. Okay. So go ahead and do that. And it choose, yeah, say, yeah. Okay. I want it terminated. So we go back to our auto scaling group. And again, let us come down and see where let us look at our activity again. Now this might take a little while. So the default cooldown, as you've seen, is 300 seconds. So it takes about 5 minutes until we actually see any scaling activity. So what do you expect to see? Over here, there's two things. When the scaling activity actually start, we should see an entry for the termination, because then it'll say, oh, I can't see you, where it realizes the instance has disappeared. So we see an entry for the termination of the first instance. Then it will start to create a new instance and it'll launch. It will take about 5 minutes, roughly. I wonder, sometimes this works, as Naveen suggested. Go ahead and refresh. See. Ah, there's a pre-end service. Remember, see this. Let me just copy this actually. Okay, so initially it launched a new instance. Then at 0547, oh God, that means it's time is correct, but not according to us, our local time. So terminating this EC2 instance, at this time, an instance was taken out of service in response to an EC2 health check. So this is where, why I'm so I'm like continually on and on about health checks today and even yesterday to some extent. Because when we're dealing with all this, we're not just deploying instances. We are deploying components that actually use instances. So there has to always know the status of an instance. So we have to set up our health checks, should be done correctly. Change the configuration of your health check, set it up as you want. But that's, whenever you are just exploring the different options. So they terminates it. Then here's a pre-in service. It launches a new EC2 instance. So at 2021, blah, 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 an instance was started in response to a difference between desired and actual capacity, increasing the capacity from 0 to 1. So there we go. There we have it. We go, and even though we actually dropped our instance, we stopped it, we terminated it, actually is gone, including the EBS volume. which was attached to that instance, that also is gone. Now, this is a cool thing that Amazon automatically it will detect, depending on your configuration, how long it takes, your health checks, configuration, setup. It'll detect after a period how long that the instance is not available, and then it will start. There we go. No, it's not there as yet. And then it will start to, it will provision another instance. And there we are. That's actually pretty quick. So now the instance is available for us. Okay, so this is what we can expect. An entry for the termination of the first instance and an entry for the launch of a new instance. Okay, so that is our first auto scaling group, and impressive, isn't it? So you can imagine in a business scenario, this helps with your uptime. So we have load balancing on the one side, which will help us with, traffic to our websites. So we have some reasonable certainty with it that our web application, is we got load balancers in place to handle traffic. But with the auto scaling groups, we are pretty much guaranteed that except for a short window, our website, our web application will always be uptime like 99% above time. Of course, it depends the response, how long it takes for your Amazon to realize that a instance is unhealthy or has been removed, because it doesn't poll, like it polls at intervals, which we can of course also configure. And once it realizes that instance has actually not available, then it removes it from service and then it creates a brand new instance and launches it and puts it into service. Now, so that is there. So this is how autoscaling actually works. Now, if we go to our instance, there's nothing much to see elsewhere, including the monitoring. So go to the instance management tab. And this is a brand new instance, not what we originally deployed. And as you can see, it's in service. Everything else remains the same. Thankfully, our status is healthy. Thankfully. Okay. All right. Now, as you can see, the instances section, it shows the new instance only. So let us go to our instances and choose that. There. As a matter of fact, I still checked it. So our instances page, it shows both the terminated instance and the new running instance. Of course, this is 051AF3, and this over here, 051AF3. 051AF3. So of course, yours will be different from mine. You can verify yourself. This is the instance that has been put into service and created and put into service by our auto scaling group. And this one was the one that was terminated. As you can see, I have only one that was terminated, so that's it. That was Everything else was actually, I had stopped it. That's fine. All right, so you'll get it. This is how it runs. The terminated one, of course, you know, it is going to stay on this page for some time. Don't worry about it. And then after some time, it will be removed from the list. So everyone is up to date, hopefully, with this. Everyone can get the same results. So everyone can has the same results as me. Have they, y'all come to the same thing? Somebody just let me know. So Naveen, are you there? Am I audible?
Audible, sir. Taking a moment to show it as successful, sir.
A
But
moment for it to start up. You said, what you said? Sorry.
means in the activity, right now it is showing successful.
Okay, okay. That's fine. It might take a little while.
Yes, sir.
It might take a few minutes. Give it a few minutes. It doesn't take very long.
Yes, sir. Sure. Sir.
Okay. If at any time I'm not audible or the screen goes off, let me know. Somebody just tell me directly or
Sure, sir.
just
Sure,
put it
sir.
on the chat. Even the chat I can't see because the window goes down. Okay, so that's that. Now, what I would, couple of things. Um, we'll come to this shortly. It's about VPC peering. We'll come to that. So anyway, just leave it, let it run. It's bound to, it'll come up at some point and just just let it run for now. It'll come up whenever, at some point. Okay, I want to talk to you for a little bit about clustering and load balancing. That's one of the topics assigned that we are expected to cover. You all have the same curriculum, I think, like I have. I received a syllabus for each day, every day, day 1 to 6. So one of them is about clustering and load balancing, but more like what's the actual difference between them? You know, so let's just talk about that for a few minutes. Now, these two terms, actually, just like high availability and fault tolerance, what we were discussing yesterday, these two terms also are also used in the same sense by a majority of IT people. You know, like it's just thrown around with no regard whatsoever. Nothing surprising about it. It can get a little bit confusing because there are similarities to some extent. Let's try and make some sense out of it. Now, clustering actually has a formal meaning. The cluster is a group of resources. All right. It's a group of resources that are trying to achieve a common objective and aware of one another. What do I mean by that? What it usually means is servers, right? It usually involves setting up the resources, servers usually, to exchange details on a particular channel port and keep exchanging their states. So a resource's state is replicated at other places as well. Okay, it usually also includes load balancing. This is why where the confusion comes in. Where the request is routed to one of the resources in the cluster as part of the load balancing policy strategy. That is our cluster. So clustering, once again, it actually involves setting up all our resources, our servers. And these EC2 instances and actually our servers, what we are doing.
So sir, as you said, while demonstrating your application load balancing, you have created a target group. So can we say that target group as a cluster like that?
That target group, exactly. One sec. No. Your target group will be actually your target group. We can't use it in that sense.
I think it is the mean
I
want
mean,
to say that
okay, it does represent the target group represents of
and
servers in
yes,
that sense, yeah. But
yes,
no,
yes,
we
yes,
can't actually create a cluster out of it.
yes, yes,
It actually represents the instances that can be targeted.
yes, yes, yes.
You get me?
Means it shows a simple
So in
instance
that
of
sense, it'll be a different route. It'll be a
yes.
different kind of path.
Uh,
So for a target group, all the health checks and this and that, everything will be in place. But no, it will just represent, actually, it's just representative of a group of instances, nothing else. Nothing else, really.
in that sense, sir, it might it may
In
be
that
referred
sense, it's
as
a
sub.
cluster.
Uh,
That is there. In that sense, it is a cluster. But practically speaking, we can't
yes,
use
no,
it
no,
for anything except,
yes, yes, yes,
you
agreed,
know,
sir.
like a list. This
Yes,
is the list
yes,
of instances I
yes,
want, my, say, my, my load balancer to target, like that.
agreed, sir.
But in that
Clustering
sense,
is
it's
an
a cluster.
yes, sir. That was my
Now, load balancing, here's the thing, load balancing can also happen without clustering when we have multiple independent servers that have the same setup. But other than that, they're unaware of each other. So if I deploy all of them actually independently, then it's not like there's no clustering involved. What I mean is we can use a load balancer like to forward requests to one server or other, but one server does not use the other server's resources. Also, one server resource does not share state with other resources. Now with clustering, basically it involves not only setting up the resources, but they exchange details on a particular channel or port and keep exchanging their states. That is clustering. Load balancing, not necessary. So basically, what am I saying? I'm saying that we can replicate a resource's state at other places as well. So that's the point of clustering. We can move state, we can replicate state from one server to the other. That's where high availability also comes in, and fault tolerance to that extent. Okay. So now with load balancing, one resource does not share state with other resources. Here's the key point to remember. So once let us just talk about the task that a load balancer usually undertakes. Here's what it does. It continuously checks which servers are up. So for our application load balancer, which you see on the screen in front of you, that uses this target group, right? And the target group actually specifies what we have deployed. You can see the target type also is given as instance. Now, when a new request is received, it sends it to one of the servers as per the load balancing policy. In our case, for the Amazon load balancers, it's a round robin policy, as we talked about before. So when a request is received for a user who already has a session, send the user to actually the same server. Now, why is this necessary? It's like this. A request comes in from a particular user, he's got a session. Now, the load balancer, contains many servers, some of them independent. They don't replicate state. So if a user comes in and for one request you send him to server A and the second request to server B and so on, he or she will never be able to get any work done. Why? The user, because the state is not replicated, you know. So we need so that your web application, it has to be intelligent enough. So it is intelligent enough. Depending on the session, it will choose a server as per the load balancing policy and send the user to the same server till he or she ends the session. However, there are certain scenarios that this is not required. For instance, when you're serving static HTML pages like how we served up, these are all static basically. This is simply a static page, right? Okay, so what does this mean from a user's perspective? Which one is better? Now, you know something about this kind of question, which is very difficult to answer. Every time someone asks this kind of question, which is like generic, frankly, which one is better? The answer, though, what can you actually realistically answer? All you can say is it depends. It's simply actually what we are, all you can say is if one was better than the other in all circumstances, then the other wouldn't even be there, right? If you have two options, one option is better than the other every time, then the second option would just go away. That's with software also. When there's certain technologies come up which is better than the preceding software in all respects, it is difficult, like it goes out of style. Anyway, so clustering saves the user state and is more transparent to the user, but is harder to set up and is very resource specific. Over here, we didn't set up any clusters. We did a load balancer. Clustering is another area. So different application servers have different clustering protocols and don't necessarily work out of the box. Very doubtful. In spite of all the marketing. So load balancing is comparatively speaking more painless and is relatively more independent of our application servers. Now, from a user's perspective, what's happening? It means that if the user is doing something on the application and the server goes down, then depending on whether the system is doing clustering or load balancer, the user observes different behavior. If the system is clustered, then the user may be able to continue doing his or her transaction. May not even realize that the server's gone down. Depends how efficient it is, how fast, you know, the clustering actually happens, the policy gets implemented. If the server is load balanced without clustering, here's the important takeaway here. The means the user state will likely be lost. And the user will simply be sent to the other servers to restart a transaction. So you can imagine in a banking and financial scenario, this would be pretty bad state of affairs. The user will have lost some work for sure. So I just wanted to talk with you all about that, about clustering and load balancing. What how to actually, what it actually means, essentially. And they are very distinct. So we cannot lump them together and put them in the same box. That is not going to happen. Okay, what we'll do something interesting now. We have right now we have our autoscaling group and we have our load balancer. Now we got our autoscaling group. Great. So let's do something. What we would what we are interested in doing is to dynamically actually allocate workload uh, in AWS using autoscaling and load balancing. Actually, what we are going to do is we are interested in setting up a scaled and load balanced application. Okay, now before that, just a few things we should understand. Firstly, we are going to put both together. So let's actually first we'll talk through. We are talking about dynamically, supporting AWS workloads with load balancers, ELBs, and ASGs, auto scaling groups. Fine. Let's break it down first. What exactly is EC2 auto scaling? Let's break that down. We've done it. We've got it running, and we've seen how it works firsthand. So is our load balancer also. We've seen how it works firsthand. We've seen from here. We've seen how it actually switches. No, no, and this is not my. This is just my instance. So we've seen anyway, like it switches from one to the other. It switches from server one to server two. Now, if I had that over here, we could see it. Anyway, whatever. So put simply, autoscaling is a mechanism that will automatically allows us to increase our EC2 resources to meet the demand. Now, this is based off our metrics, which are custom defined, and also our thresholds. We have already, like we define 111, desired capacity 1, minimum 1, max 1. So at any cost, AWS has to provide an instance to us if we terminate it. Which is what we did. Let's look at an example. Now let's think about it this way. We have a single EC2 instance, which is acting as a web server, and we've seen this. We've done it ourselves. It receives requests from the public across the internet. So as the requests increase the demand, so does the load on the instance increase, excuse me. And the additional processing power will be required to process the additional requests. This is all obvious. You'll understand this, but let me just lay it out once again so we know what we are dealing with. Therefore, the CPU utilization will also increase. So now to avoid running out of CPU resources on your instance, which would lead to obviously poor performance experienced by the end users, you would need to deploy another EC2 instance to load balance the demand and process the increased requests. Now, with autoscaling, we can configure a metric, which we have done, to automatically launch a second instance when the CPU utilization gets to like 75% of the first instance. Actually, that is also there. That's possible. Now, by load balancing traffic evenly, it would reduce the demand upon each instance, right? That's logical. And it would reduce the chance of the first web server failing or slowing down due to high CPU usage, because that can happen. I mean, you'll have heard so often that you can overload somebody's website with so many, like millions of requests, and it'll crash their web server. That, right? Those are attacks. So, in this sense, your first web server could fail or slow down due to high CPU usage. Similarly, when the demand on your web server reduces, so would your CPU utilization. So you could also set a metric to scale back. Now, in our example, like we can automatically set auto scaling to automatically terminate one of our EC2 instance when the CPU utilization drops, like say, to 20%, because it's no longer required due to the decreased demand. So scaling our resources back will help us to optimize the cost of our EC2 fleet of instances. As we, with everything else on AWS, not everything else, there are many plans, but is pay-as-you-go pricing is the most popular option, I would think. So, but not only pay-as-you-go, but pay for resources while they're running, like our Lambda functions. You could have your Lambda sitting there 24/7, doesn't mean you're paying for it. Only when the code executes that you incur a charge or cost. So basically, through these customizable defined metrics, we can actually increase, or what I mean, scale out or decrease or scale in the size of our EC2 fleet or instances automatically, very easily. So let's talk about the key points. The advantages are, one is automation. This actually, as you saw yourself, it provides automatic provisioning based on these custom defined thresholds we have set. So that means our infrastructure actually becomes elastic. Our actual infrastructure. That's not a small feat. So our infrastructure can elastically provision the required resources to prevent, actually our operations team then has a lot of, their burden is less. Otherwise, it's up to them. With dedicated servers, like how we used to do traditional hosting, the operations team was in charge of deploying and scaling in and scaling out. It was them. So we don't need to manually deploy and remove resources to meet demands put on the infrastructure. Then the nice thing is the greater customer satisfaction, because none of this will exist without the customer to pay for it. So if we are always able to provision enough capacity within our environment when the demand increases, then it's unlikely our end users will experience performance issues, which will help with user retention. Then there's cost reduction. We have the ability now to reduce the amount of resources when the demand drops. So we stop actually paying for the resources, at least as far as Amazon AWS is concerned. We only pay for an EC2 resource when it's up and running. As soon as we terminate it, remember, we stop paying for it. Even the resources that you have, that you and I have. So when you don't need it, actually delete it. Just clean up. Don't just keep it lying around unless you're using it. Delete it. You need it again, do it. Which is something I also have to go and do myself because we get 30 GB. Just to remind you. Now we pay for EC2 resource once again when it's actually on, when it's running, and that too on a per second basis. All right. Now here's where we come down to what we are, the nitty gritty. When we couple an EC2 like EC2 auto scaling with an elastic load balancer, we can get a real sense of how, building a scalable and flexible architecture for our resources can actually be. Okay, so that's what we can go ahead and we can start on that now. So let us see also if we can reuse some of what we've done. We've created our load balancer. We've also created our auto scaling group. So what we are going to do is actually we're going to set up a scaled and load balanced application. So what this is not only what do you call it? It's not only high availability. This is actually going to increase our fault tolerance. And you remember the distinction bit from our last session. There is a distinction. Fault tolerance is like the older brother of high availability. Now, what we are actually going to do, we are going to take our auto scaling group and we are going to register it with our Elastic Load Balancer. Okay. So this was going to help us set up actually a load balance application. Now, what it does is that Elastic Load Balancing, it works with Amazon's EC2 auto scaling. What it's going to do is going to distribute the incoming traffic across healthy Amazon EC2 instances, of course. Now, this will increase the scalability and availability of our application. Now, our elastic load balancing, we can enable within multiple availability zones, and that is what is going to increase the fault tolerance of our applications. Now, in any case, we have, let us take a look. This is our load balancer. We have multiple zones. We can just leave it as that. We have 2 available zones. East to B, East to A. Auto scaling group actually has 3. We selected all, right? So that's good enough. That's what we need over here. All right, what next? Now our architecture is actually going to look like this. After we finish, of course, by the time we finish, architecture is going to look like this. So we, as you can see, we got our users and the requests coming over HTTP and HTTPS. We have our region, which you can see in your navigation pane. Here we have created a virtual private cloud. All right. And then within that, we have created uh, within our VPC, we have created an application load balancer. See that purple looking thing, that is ALB, that actually we created it already. And then our ASG is down below the 4 arrows. Right, we've got our AL, the load balancer connects to our auto scaling group. In this particular diagram, we have actually for us, this is exact. Our auto scaling group does contain 3 availability zones when we created it, right? And okay, here's all our instances. So it's on these lines. This is what it actually looks like. This is just a basic architecture, nothing else. It's not about flow. Okay, so before we actually get started, let us check out our load balancer and let's see that it meets everything. Now we have our availability zones. Okay. And let us see our target group. Here's our target group, which is associated with our load balancer. Let's take a look. These are instances. Fine. So that seems okay. Now the load balancer is very important, that our load balancer, that's why you saw me taking all these screenshots. Our load balancer must have the same availability zones that are in our target, ESC. So here's our availability zones. We have US East 2A, US 2B. ESG, I'm pretty sure I had copied it. Anyway, since in this region there's only 3, it's bound to, it's the same. But we didn't choose. As you can see, for our region, we have 3 availability zones and we use 2 for the load balancer. For ASG, if you go and check, I know that it's going to have, it has all 3. For high availability, you choose multiple availability zones. So that is the first requirement. Now the next requirement we have is we need a security group, which we have actually defined. Let us go to our security groups. These are all the checks. We already got most of it created. So this is our ALBSG. This is what we were using. And this looks okay. As you can see, we can SSH to it. So we can connect on this port. And also we can HTTP to it on port 80. So that is fine. That is a second requirement. Then, of course, along with all this, we are taking the most very basic setup, but we can, if we wish, we can also create an identity and IAM role. That is also there. Then, of course, we need our virtual private cloud. That is there for all of them. So we are using the default virtual private cloud, remember? So that is fine also. So ASG is, I wonder if it's over here. It'll be, here's our launch template. Here you can see your IAM instant profile and all that if you wish. All right. Now we should have a launch template, but we've already created it. This is our launch template, which we created for our auto scaling group. Okay, so it looks like we're more or less set. So we will start from here. You'll see. So when we're starting, we are actually keeping our ASG as part of our, you know, we are bringing in, we are attaching our ELB to our ASG. So we will create a brand new auto scaling group. Okay. So we have a launch template. We have a security group specified. So I think, okay, what else is there? Then we use for our auto scaling group, we actually use a machine image. Then for our load balancer, we had two instances. You remember we had two instances on which we installed Apache, and then we created our index.html file. Okay, so first things first, let us create an autoscaling group. So this is our first one. Give it a name, some nice name, whatever you know. Um, just call it usual kindergarten name is fine also. My first ALB ASG. Okay. Now, the great thing is that we've got that, no? Our launch template, auto scaling group LT. Now this ESG launch template, let's see what we had done before. We've got a security group. This is ALB, 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 ESG. Here's our launch template. We are just, so everyone's on the same page as me, right? I hope. Let's take it, it has to be done carefully. We've got our launch template. This is what we created for our initial ESG. Then that was okay, yeah. Okay, so we will reuse that. We don't need to create a new one. I'm just checking whether we actually need to create a new one or no. But no, we can actually simply reuse this. All right, so here we have, now we are in our configure purchase settings. This must be enabled for you, please. Because I got a bit of a surprise when I came to this page once and I had a grayed out option over there, you know, and it was giving me all these options for, purchase this and that and on demand and all this stuff. Oh, anyway, whatever. For our network, now we'll have to specify our subnets. This is our default VPC. Network. Okay. Now we select our subnets. So we have three, 2A, 2B, 2C. Now in our original ESG, we had actually three. Actually, whatever subnets were there, we simply chose all of them. That's fine. That was so that, we have high availability. Our launch template, okay. No, that's fine. That's done. Okay, just one check. Let us see the availability zones for our ALB. So our ALB, here's this. I hope you'll remember which are the availability zones, unless you'll have made a record like I've done. But anyway, there's only a few availability zones for each region. So I think y'all can remember which ones. You probably selected the first two, like I did for IALB. So we have US East 2A. Basically, what we are doing over here is we are choosing one or more subnets from each availability zone that we want to include. That is actually what we are doing. And this is auto scaling. It doesn't make sense to have one availability zone, does it? Now you have to base it off the availability zones or load balancer name. So in this particular case, I have, okay, a VPC is fine. F45C, a subnet is ES2A, and then a subnet is also ES2B. I'm going to just keep these two availability zones. I'm matching it against my load balancer. All right. That's all I'm doing right now. Okay. So far, so good. All right. So now that we have our subnets in place, we can go ahead and we can actually, we can once we click next, we come to this page. It's pretty neat. I think this is the newer kind of template that is in use for this, because it's got all these steps over here, so we know exactly where we are. All right, so now we on the configure advanced options under load balancing. So that's why we're not going with our original. Well, we are not creating a new load balancer, but we are creating a brand new auto scaling ASG. We just select attach to an existing load balancer. Now we get ALB year. Let here's my ALB. So this, when we are actually attaching our load balancer, we are attaching realistically. We are not attaching our actual load balancer. We are attaching the target groups that are configured for our load balancer. Just remember that, because the target groups, right, they specify what that load balancer actually targets. When it has multiple, user requests come in, it has to distribute a load. So we just select, choose, attach to an existing load balancer, and then choose your target groups. Okay, now we come to our health checks. Now, before we didn't have, we have EC2 that is there checked by default, but now we have a elastic load balancer, so we can check it. So go ahead and do that. We haven't come up to CloudWatch. I think CloudWatch is maybe the last day of this training, so leave this alone. Without understanding, there's really no point implementing something. You must understand it thoroughly first and then go and implement it. So that is that for here. Okay, so now actually we can accept the defaults, but let's go through it in any case. We can leave this also. You can experiment with it, on your own. That is also, that's fine. You're encouraged to do so, but for now, we know that we want at least a minimum of one instance always in service. So let's go over here. This is none. Yeah. Let's go to, if I remember correctly, in this case, I don't think we can add tags. I'm not sure we can add tags. Anyway, whatever. Maybe I'm thinking of something else. Okay, now we can, I think, go to our review page. Okay, so here's my auto scaling group, the launch template that I originally made. It also contains a security group and actual instance and all that stuff. We have that is over here. We've got a load balancer setup, my ALB, our health checks in place, our groups, all this stuff is there. Okay. Now we can create our auto scaling group. Okay, so this was actually created successfully. Now here's the thing. When we create, you notice we actually haven't done anything. We haven't associated the ASG explicitly. We haven't registered any instances. Okay, it's like this. When we create the auto scaling group with a load balancer attached, that means the load balancer automatically registers new instances as they come online because it's the ASG that is responsible for actually creating those new instances. Right. So, okay. So it's a ASG. So the load balancer will automatically register it as they come online. So we only have one instance at this point. So actually there's not much to register. So normally we don't need to actually by manually register our instances. Okay, let's see. Let's select this. Now on the go to load balancing. So the load balancing this on the details tab, just come scroll all the way down. You'll have load balancing will show the attached load balancer like target groups. These are your target groups. Okay. Now let's go to our activity tab. And in the activity history, let's see what we have. Okay. So here we have is launching a new instance. All right, because nothing was there. So the capacity initially was 0, then it's become 1. Let's go to our instances management tab now. And thankfully it is healthy. Really, because sometimes I've had problems occasionally. All right, so the status where this is it actually. Here's health status. It's saying in service. Otherwise, if it's not ready, it'll show pending. It might show for you, it depends, you know. But if it's showing in service, then it's ready to actually receive traffic. Okay. And of course, this health status, this status is fine. Da, da, da. The health status column actually, as you know, it shows the result of the Amazon EC2 auto scaling health checks on your instances. And here's the thing, we have to be a little careful with the health checks because although an instance may be marked as healthy according to, the health checks performed, the load balancer, this is our auto scaling. I will just want to point out, keep in mind that this is a health checks from the auto scaling group. But the load balancer is, it will only send traffic to instances that pass the load balancer health checks. Okay, doc? Reasonable enough. Okay. So our target group ASGLT, that is fine. That is fine. Instance ID. All right. Let us go to our target groups page, please. And we have reused our target group. This is the target group. Okay. This is the target group that we have specified. Remember, when we attached our load balancer, we didn't attach our load balancer. We attached the target groups of the load balancer. They have to be the same. So now our details, we can take a quick look. Here's my load balancer that is there. Thankfully, everything is healthy, thankfully. Otherwise, we'd be sitting around twiddling our thumbs while we try to reconfigure everything. Let's go to our targets page. And here's our targets. So it's the state of our targets is, sorry, instances. So targets. So once it is healthy, okay, once it is healthy, then they are actually ready for use. So this is INST2, INST1, ELB, ASG, blah, blah, blah. These are the actual instances that we set up. So the instances are there. Let's go back. Okay, so that is how we actually set up. This is how we actually set up, we connect. This is how we actually connect this is how we do dynamically allocate workloads in Amazon using a load balancer hooked up to an auto scaling group. Okay, so I hope everyone's got through that. Fine. And as you know, if you want to actually check out your load balancer that is operational, you can simply take your DNS name and copy it in. And you can see your DS, your server, your load balancer is operational and is passing in requests in a round robin fashion. All right. So we have managed to put together. We managed to set up an actual scaled and load balanced application. And we actually reused it. It's not much work. We have to create a load balancer. So it's not like we have to do everything from scratch. Not like we're developing a virtual private cloud from scratch. Once you have your load balancer and you understand what you want from your ASG, you create your ASG and you reuse your load balancer because your load balancer already contains your lodge template and the security group. The security group, remember, has to accept requests on port 80 basically. And if you want to connect, then you should allow, I do it just by default. It should allow connections on port 22 so you can SSH into your instances. But actually that is not required, but mainly HTTP port 80, it has to accept requests. Now there's one thing the next thing we are going to do is, you all might find very interesting, but it is long. We won't finish it today, but we can start. Mr. Charan will be taking.
Sorry to say that, sir, today you only are going to take the last session as per the information.
Sorry, Naveen, you're a little bit soft.
Now I am audible, sir?
Yes. Now it's better.
Sorry to say, you only are going to take the last session as per the information received.
I will take the last session.
Yes, sir. Yes, sir.
Oh, okay, great. Because the next one is actually pretty long.
Yes, sir. Yes, sir.
It's pretty long. We have to implement it. We have to do quite a number of things. So we won't finish in half an hour, I know.
Yes,
So
sir.
great. Okay, that's fine. I will take the last session. That's fine. That's cool. Perfect. All right. So I'd like to talk about we should this one of the things we have to do is about VPC peering. As a matter of fact, what are we actually going to do next? Okay, we may as well talk about that. It's to do with VPC peering. We are actually going to build a two-tier architecture. That's why it's even though it's a basic two-tier architecture, but it's great. We'll have fun with it. Sure. So we're going to have fun with this. We are going to set up what I like to do with y'all is set up a basic two-tier web application in Amazon Web Services. It doesn't sound as basic as it is. We have to work on it. Okay. So anyway, we have time. That's all right. So what we actually have to do really is okay, you understand the basic thing that we are going to build a two-tier architecture web application. And now, firstly, we're going to create a virtual private cloud. We'll use a default. So because that'll take some of it. And we set up this infrastructure to support a basic two-tier CRUD, which you all know is create, read, update, delete application in Amazon Web Services. Okay. Firstly, let us Let's talk a little bit about, so we see actually we have a number of parts, components to build for this. Let's talk a little bit about VPC peering. What actually, what is that? What's happening over there? So just take a look at this. This is a basic, we already know about our virtual networks, right? So we built one actually from scratch. So our Amazon Virtual Private Cloud, Amazon VPC, it enables us to launch AWS resources into a virtual private network that we've defined. So a VPC peering connection is a networking connection between two VPCs. And so we have two VPCs here, VPC A and VPC B. That enables us to route traffic between them using this private IPv4 addresses, as you know, or the IPv6 addresses, which are public. That's how we connect to the internet. Now, instances in either VPC, virtual private cloud, can communicate with each other as if they are within the same network. So we can create a VPC peering connection between our own VPCs or with a VPC in another AWS account, right? Got it.
Sir,
Between
it
our
will be
own
more.
virtual private clouds are also crossing over boundaries into another. As long as it's an AWS account, we can also peer into it, peek into it. So the VPCs can also be in different regions. That's very interesting. This is also known as an inter-region VPC peering connection. Now, Amazon uses our existing infrastructure for VPC to create the VPC peering connection. Now, what is it actually? Can you see on the slide? It's neither a gateway nor is it a VPN connection. It does not rely on a separate piece of physical hardware. There's no single point of failure for communication or bandwidth bottleneck. Now, VPC peering connection helps us to facilitate the transfer of data. For example, suppose I got more than one AWS account. We can peer the VPCs across those accounts to create like a file sharing network. We can also use it to allow other VPCs to access resources you have in one of your VPCs. That's the peering connection. That's what it does. Now, we can establish peering relationships between VPCs across different AWS regions, as we mentioned. Okay, so what does this actually boil down to? It allows VPC resources, including EC2 instances and Amazon RDS databases and Lambda functions that run in different AWS regions to communicate with each other. Ah, my,
Sorry, sir, it's Naveen.
yeah,
Sir,
sorry.
I have a question. Since we know that VPC pairing is used for sharing the resources, so in that
What kind of
connects
resources?
means like a file or something else.
Yeah, I'm just coming to that. Right, right, right. What kind of resources can be used? When we say BPC resources, what does it actually, it means our EC2 instances. Amazon, like we have Amazon RDS, Relational Database Service, Amazon RDS databases, Lambda functions that are part of, actually whatever resources belong to your virtual private cloud, but Amazon type resources. Whatever is actually, you can upload stuff to Amazon also, that'll become a VPC resource if it's part of the virtual private cloud. But commonly what we are talking about, we're talking about sharing servers, which are EC2 instances, databases, files, yes. But then we go through, remember we are using AWS. So the file storage, normally we would use something like S3. You remember that hands-on we were doing, that demo we were doing on using Lambda functions. We did a file uploader. To actually get that demo hands-on to work, we actually had to create a S3 database, a storage area, excuse me, which is very simple. It just creates a bucket for you in which you can do dump stuff. So in this situation, files also, you want to, obviously, with Amazon Web Services, if you cannot share resources across, I mean, organizations, so file sharing is very important. Definitely. What options you use, like generally you'd use S3. S3's EC2 and S3 are the most commonly used services in Amazon, actually. All right. So files, you would use S3 for that, file sharing. So anyway, so these VPC resources like our databases, instances and all that, Lambda functions, whatever it is, they can run in different AWS regions and they can communicate with each other. How they communicate is actually using private IP addresses. So they don't require gateways or VPN connections or separate network alliances, nothing. The traffic remains in this private IP space. So all inter-region traffic, Amazon very heavy on security, of course. So it's encrypted. There's no single point of failure or bandwidth bottleneck. Actually, we can think of it and let Amazon handle it. Just think of it that way and it's off your mind. But to understand how it's going, so traffic will always stay on the Amazon, the global AWS backbone. What do I mean by that? I mean it never actually uh, sets foot, it never traverses the public internet. It's on the Amazon backbone. So that reduces threats such as, like DDoS attacks and common attacks, exploits. So inter-region VPC peering will provide a very simple, cost-effective way to share resources between regions or to replicate data between these geographic regions. Now let's come back to VPC again, Amazon Virtual Private Cloud. What it actually enables us to do is to launch AWS resources, right, into this virtual network that we've defined. So that's the thing about a VPC is very powerful and it also runs, remember it runs on the global AWS backbone. So it's threat is minimized. Threats are actually minimized this way. The other thing is that end to end, all the data that you send is encrypted. So there's two things you can do. You can share resources like files that you're asking about. The other thing is sharing files is there. And the other thing is you can replicate data. like databases. Data replication is easy enough to do. Okay, so let us do a little bit of our setup right now. Actually, what kind of communication resource sharing will take place between VPCs? We can communicate with public IP. No, 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 no. No, no. Let me just let's backtrack a little bit. This is security is very important. So how it actually communicates, it doesn't go through, there's no like network sharing. I mean, there's no protocols or anything specific like that. It's all takes place, you're on the right track, but halfway. It doesn't take place over public IP, it takes place over private IP. Once your VPC peering connection is done, so it all the communication will take place over private IP. So that way it's correct, but public IP, no, because your security will be compromised. But in any case, it's still very good. I mean, it's perfect because otherwise to communicate securely, you'll have to have a lot of stuff in place. A lot. Your network protocols and stuff like that, for instance. So it would be a little too much. So what do you say? Let us get started on building a two-tier web application. So the first thing we'll need to do is, here we are in our EC2 dashboard. First thing we need to do is go and we will create our VPC. So recently visited, just open your VPC dashboard, please. So VPC is, remember, is basically what are we doing? We are creating a virtual network to deploy resources. Okay. This is also pretty simple. So the VPC wizard, we don't even need this wizard. Just come to your VPCs. I don't want to go through the wizard actually. Just go to your VPCs and create VPC. It's not necessary for the wizard, frankly. And over here we have a create VPC. Let's take that. All right, we'll come to this page. The wizard can be more, sometimes more confusing than not using it at all. So give a name to the VPC. Give it anything. Give it some kind of meaningful name. Maybe let's do it like this, so we know where we are. Two-tier VPC. All right, and we'll enter the CIDR, like how we were doing in our private virtual cloud. Okay. CIDR, by the way, is it's just another acronym for classless inter-domain routing. Inter-domain, classless inter-domain routing. So that's what we need to put in over here. And as we saw before, we have to specify this block. So this we have to do properly. This gives us a big range, frankly. It's something around 65,000 or something like that. I think the default's okay. The tenancy info is also okay. So that's that. Nothing else we need to do over here right now. And we can go ahead and create our VPC. So let's see, it's already available. That's fine. Here's a CIDRs. That is there. For virtual VPC, this is a little bit of a difficult thing. Your CIDRs must always be constructed properly. And that is actually left up to us to actually specify it. Okay, so here we are now. As usual, we'll have to create our subnets. So choose the subnets option from over here. Oh, we do have, I have all this left over, which I should have cleaned up. Anyway, so what we are going to do, we are going to create 3 new subnets. One is for our application and 2 is going to be for our database. Okay. And also our subnets are tied to availability zones. So it's going to be like this. We'll choose, we choose different availability zones for our database. Okay. Once again, 3 subnets, one for application, two for the database, and we'll choose different availability zones for the database subnets. So let us actually create, here's our 2-tier VPC. That should be okay. Now, availability zone, let's see what we have. We got East to A, East to B, East to C. Fine. But this, what we see over here, that is also fine. 10.0.0.0/24. 10.0.0.0/ that's okay. This is for our application subnet. Okay, we need another 2 subnets. 2-tier VPC. So I had 2-tier. Subnet 1. For this, we availability zone, I guess we can keep it like this. 10.0.1, the 0/24, that should be okay. I'm going to keep this as a record because we might need it again. Okay, so that seems okay. We've taken this availability zone. That's all right. 2-tier. Okay, everyone with me so far? We can go ahead and create a subnet. One more subnet to do. 2-tier database subnet. Create one more. 2-tier VPC. Okay. 2-tier database subnet 2. Availability zone will be, let's take the last one. We can put this at 10.0.2.0 and then 24. Let's see, 10.0. That should be all right. Okay. Okay. I think that's that. Then, okay, now we can create our subnet. Okay, doke. Now, like we did before, we have to create a route table. Now, how are we going to do this? Do we need 2 route tables for database? We have 2 database subnets? Nah. We need one we will create one route table for our application subnet, and we'll create one which will be shared by both the database subnets. Then once we have that done, we will explicitly associate each route table with its subnets. So first we actually create that route table, then we'll add in the subnets. Okay, so let's do that. Let's create our route table. All right, so this is 2-tier. Now this route table is going to be for our application. So 2-tier application route. We take our VPC, 2-tier VPC. That's all it takes to do our route table. Later, then we will add our subnets. Okay. Now directly, we've got this created directly. Let's go to Subnet Associations. We go to Edit Subnet Associations. And now we've got our names over here, so it's a little bit easier, isn't it? So let's do this. Let's do it now, otherwise rather than later, because we have to do the same thing for our database subnets. Database route table. And that's that. Let's see our subnet associations. Here's our subnet association. This is explicitly done. Here's our routes. Route is active. Back to our route table, we need to create one route table for both our databases. So it's oops, 2 dash tier dash database. Okay, that's fine. Now we are going to attach both subnets to this. Okay, so let us create our route table. Okay, fine. So we're making progress. Before we break for lunch, then last thing we'll do is take very little time. That is, we will create our internet gateway. So let us create our internet gateway. 2-tier-ig. That's enough. That's all it takes. Now this has to be attached to the VPC. Otherwise it won't know where to go. So that should be there. Now come back to your route tables and select your application route table. Let's select the application route table. Let's add a route over here. This is normal, that's fine. Leave that as it is. We're going to add a route over here. Now the destination is just this. And you understand what that means. There we go. So you understand what that means. It's basically targeting the internet gateway. All right. So make sure your target is over there like that. Let's save our changes. And it is active already. So, okay. So we've done quite a bit. I did say this is not so simple. We have a lot of stuff to do before we can set up a full two-tier architecture. But okay, because we have other stuff to deal with like security, then we have to set up our network infrastructure. We have to deal with NACLs. There's network access controls. We have to set up our database. And so we have a lot of stuff to do, you know. But anyway, we made a good start. So thank you all. I will see you all, I believe, at this next session is being taken by your guest speaker. So I will see you all in the last session, the fourth session.
Yes, sir. Yes, sir.
That's correct?
Yes, sir.
Right?
Correct.
Okay, great. Okay, so y'all can leave for lunch now. I will see you all in the fourth session. Thank you.
Thank you, sir. Thank you. Good afternoon, sir. Good afternoon, participants.
Good afternoon, ma'am.
I'm profoundly delighted to take an opportunity to introduce our guest, Dr. E. Srinivas Reddy Garu, Professor and Principal, University College of Engineering, Acharya Nagarjuna University, Andhra Pradesh. Dr. E. Srinivas Reddy Garu has done his MS from BITS Pilani, MTech from Visvesvaraya Technological University, Karnataka, and completed his PhD in Computer Science and Engineering from Acharya Nagarjuna University. He has vast
Hello, is it audible?
Yes, sir, audible. Yes, sir, audible.
Can I start the session?
Yes, sir, yes, sir.
Okay.
Audible.
Yeah. He has vast experience in teaching, administrative, and research. He has served many positions in Acharya University, Acharya Nagarjuna University, include Vice Principal, Dean, and Principal, University College of Engineering. As a dean, sir has introduced many amendments in education like semester system and choice-based system from first year, gap year concept, summer internship in third year, life skills and soft skills as audit courses, MOOCs and foreign languages from first year as add-on courses. Sir has involved in many state-level activities, which includes Regional Coordinator MSET 2013 and 14, Regional Coordinator PGE Set 13 and 14, University Nominee MSET 13, 14, 15 Committee APS-CHE. University Nominee ESET 2013 Committee APS-CHE, University Nominee PGE Set 2011 Committee, Member Strategic Executive Committee, Jawaharlal Nehru Technological University, Kakinada, Andhra Pradesh, and many more. Sir has received many Best Teacher awards in his career, and as a career counselor, Sir has conducted more than 50 personality development and career counselor camps. Sir has contributed many e-lessons in image processing, design and analysis of algorithms, microprocessors and microcontrollers, and many more. He also produced more than 50 textbooks for ANU CDE engineering programs. He has published 78 journal articles, 45 conference papers, 10 book chapters, and 5 books in his credit. Now, on behalf of STTP team, I request E. Srinivas Reddy Garu to take over the session and cast the light of his knowledge upon us.
Thank you, madam.
Thank you, sir. Please
Thank
continue,
you,
sir.
The management of KL University and all the faculty who has involved, and also Amarendra for inviting me to give a lecture on national education policy. It is very difficult to give lecture on a national education policy within 1 hour. Anyhow, I will try to bring out the important aspects of the national education policy. NEP actually aims to ensure the India, which is lagging behind in education before it completes the 100 years of independence. Unfortunately, we are celebrating this year as 75th year of independence. So after independence, within 75 years, there are only 4 national education policies was come up. The first education policy was in 1968. The second education policy was in 1986. And third one is 1992. And now the fourth one is in 2019. So this new education policy 2019, or we can call it as 2020 also. It was drafted in 2019, but it was started implementing in 2020. So it addresses the challenges for youth and we call a student-centric and futuristic policy document. Both we have both pros and cons regarding this new education policy. More than 1.5 lakh, whatever maybe we can consider this as appeals, or we can say it as contradictions, they came on this education policy. But anyhow, when compared with other education policies, this is one of the policy which has many number of changes in it, drastic changes, many number of drastic changes. As if if the central government is able to implement all these changes, definitely our education system, Indian education system, is going to change its face. So let us see the fundamental principles of this policy. So recognizing, identifying, and fostering the unique capability of each student by sensitizing teachers as well as partners, parents, to promote each student's holistic development in both academic and non-academic spheres. As I already told, this is a student-centric education policy. So that's why the main principle behind this policy is to promote the students' development, students' holistic development. So accordingly, the highest priority to achieve functional literacy and numeracy by all the students by grade. So we are lagging behind in the literacy, GER, gross emolument ratio, At least the central government is assuming that at least by 2035, at least 50% GER must be made in the country. And again, flexibility, so that learners have ability to choose their learning trajectories and programs, and thereby choose their own path in life according to their talents and interests. So coming education policy will give more freedom and more flexibility to the students who can select different subjects from different curricula. There is no need to accustom for a particular discipline. That means if a computer student is needed to study only computers, there is no need. He can take like music or art, anything as another subjects also. This type of multidisciplinary policy is going to be implemented by this NEP. No hard separations between the arts and science, between curricula and extracurricula, between vocational and academic streams, in order to eliminate harmful hierarchies among and silos between different areas of learning. So as I told, in coming years, there is no difference between the arts, sciences, and curricular and extracurricular. Until now, some engineering students may feel that we are very great, and some art students may feel that they are some backward, since they does not have any demand. But in coming years, the education policy is going to give same importance to every discipline. Multidisciplinary, a holistic education across the science and social sciences, arts, humanities, and sports for multidisciplinary world in order to ensure the unity and integrity of all. Today, a computer science student cannot do anything. If he knows about medicine, if he knows about agriculture, he can do miracles. That's why if all the disciplines combine together, we can do miracles, and the technology can be used for the development of the country in different areas. That's why the NEP is going to encourage multidisciplinary universities also. Emphasis on conceptual understanding rather than rote learning and learning for exams. So this is also very, very important policy. Until today, mugging, rote learning is given importance, mugging is given importance. Now, in this policy, conceptual learning, they are going to develop a framework for the conceptual understanding. Creativity and critical thinking to encourage logical decision making and innovation. Ethics and human and constitutional values like empathy, respect for others, cleanliness, courtesy, democratic spirit, spirit of service, respect for public property, scientific temper, liberty, responsibility, equality, and justice. All these values, all these elements are not present in nowadays education. I am very dare to say in today's education, values are degrading. So most importance in this policy is given to values. So promoting multilingualism and the power of language in teaching and learning. I think all of you know, engineering also going to be taught in the local languages. In the present year, 11 institutions are going to teach engineering subjects in local language. Let us see what is the outcome, whether it will be fruitful or it will be some educationists are saying it is absurd to teach the engineering subjects in English. The students will lag behind in getting the jobs in multinational jobs. And some are arguing that it is better to teach engineering subjects also in mother tongue so that students will be more understandable and they learn more concept when we teach in the mother tongue. So both 50% is there. Anyhow, let us see what will happen after 1 or 2 years, whether they will perish or not. Focus on regular formative assessment for learning rather than summative assessment that encourages today's coaching culture. Extensive use of technology in teaching and learning, removing language barriers, increasing access for Divyang students, and education planning and management. Now Corona has came and it has changed the entire face of education, and the teacher is also losing his existence due to the technology. So technology in teaching and learning is more and more increased. So this is another issue. All the teachers must think over. When the technology is going to play a vital role in teaching and learning process, then teacher cannot be existed there. There is no existence for teacher. So there is a question mark. Why there must be a teacher? So teachers must be able to learn current technology and also must be cope up with the technology what is going to appear here, and they must prove that teachers' existence must be there. And similarly, respect for diversity and respect for local context in all curriculum, pedagogy, and policy, always keeping in mind that education is concurrent subject. So this is very, very important point. Always keeping in mind that education is concurrent subject. Full equity inclusion as the cornerstone of all educational decisions to ensure that all students are able to thrive in education system. Synergy in curriculum across all the levels of education, from early childhood care and education to school education to higher education. At present, there is no continuity in education from school education to intermediate education and intermediate education to higher education. There are large barriers between these levels. So these barriers must be filled up, and a smooth transition from school education to intermediate education, intermediate to higher education must be there. That is also going to be worked out in the new education policy. Teachers and faculty as the heart of the learning process, their recruitment, continuous professional development, positive working environments, and service conditions. All these are also going to be reshuffled in the new education policy, as is the teacher is the main element in the learning process. A light but tight regulatory framework to ensure integrity, transparency, and resource efficiency of the education system through audit and public disclosure, while encouraging innovation and the out-of-box ideas through autonomy, good governance, and empowerment. So more autonomy is going to be given to the education institute to empower them. Outstanding research as positive for outstanding education and development, continuous review of progress based on sustained research and regular assessment by educational experts. A rootedness and pride in India and its rich, diverse, ancient and modern culture and knowledge system and traditions. Education is a public service. Access to quality education must be considered a basic right for every child. substantial investment in a strong, vibrant public education system, as well as the encouragement and facilitation of true philanthropic private and community participation. So philanthropic community must be also come forward to support the public education systems. So these are some of the fundamental principles they have kept in the view to develop the education policy. Now let us see what are the current problems that are faced by higher education system. Based upon these problems only, the education policy will be evolved. So if you see the current important problems which are faced by higher education system, then it is very easy to develop a education policy. So first of all, now the higher education system is severely fragmented. Severely fragmented. Agriculture, it is different university, different administration. Medical, it is different university, it is differently managed. Technical university, technical department, technical education department. That is, like this, total higher education was split into many pieces and fragmented. There is a major problem in the current education system. Less emphasis on the development of cognitive skills and learning outcomes. So today's education system is totally supporting the rote learning. Just marks. Nobody is worried about cognitive skills and learning outcomes. Simply we are writing on the syllabus books what are the learning outcomes, POs, APOs, and outcomes for NBA or something. But really, if you measure the cognitive skills and learning outcomes of students, it is very, very sad. A rigid separation of disciplines with early specialization and streaming of students into narrow areas of studies. This is also very important. Limited access, particularly in socio-economically disadvantaged areas with a few higher education institutes that teach in local languages. So there are many barriers, social barriers, economic barriers, linguistic barriers to achieve the higher education by the students. So to overcome this, there are some measurements are taken in the new education policy. Limited teacher and institution autonomy. So autonomy is also very limited at present. So new education policy is going to give more autonomy for both teacher and also education institute. Inadequate mechanisms for merit-based career management and progression of faculty and institution leaders. Lesser emphasis on research at most universities and colleges and lack of competitive peer-reviewed research funding across disciplines. This is also the most important point. Most of the research today in our India is fake research, fake journals, fake PhDs, and fake research. All over the world, if I take these statistics, in India, there are UGC has recognized 138,000 journals. Among these, 30% of the journals are fake journals. Before last year, 15,400 papers were published in 448 open access journals. Average amount for these open access journals is $500. $2.4 million business was done only through these journals. And the government is also not investing much more on the research, less than 1% in GDP. In the world, 25% of the fake journals are coming from India only. And that too, 25,000 journals from Tamil Nadu, 2,500 journals from Uttar Pradesh, and 2,000 journals from Karnataka. Some of the universities are also awarding the fake PhDs. I don't want to name them. So like that, fake journals and fake PhDs are now in the front, this one. That's why to avoid that one, emphasis is made on the research in the most of the universities and colleges. Suboptimal governance and leadership of higher education institute an effective regulatory system. The regulatory system also there are many problems in the regulatory system of higher education. That also must be restructured. So restructure is going on in the new education policy. Large affiliating universities resulting in low standards of undergraduation. This is mainly due to the population. I can say this is the population. Among our population, around 2.67 crores of the students are going for bachelor's degree. Whereas in China, 2009 crores of the students are going for higher education. So more pressure is on the bachelor's degree, undergraduate education. So when the population is more, which are going to undergraduate education, definitely standards will reduce. It must be also taken into care. Moving towards multidisciplinary universities and colleges with more higher education institutes across India that offer medium of instruction in local and Indian languages. Moving towards more multidisciplinary undergraduate education. Moving towards faculty and institutional autonomy, revamping curriculum, pedagogy, assessment, and student support. Reaffirming the integrity of faculty and institutional leadership positions. Establishment of a national research foundation. This is one of the most drastic steps. And establishing the National Education Research Foundation. చెప్పండి నేను పంపిస్తాను ఇప్పుడే పంపిస్తాను. శంకరావు శంకర్ మస్తాన్ని పోయి లెటర్ తీసుకెళ్ళి ఎగ్జామ్స్ వెళ్ళాము మనం మస్తాన్ అక్కడ పడేసి వెళ్ళాయంట. సో సారీ ఫర్ ద డిస్టర్బెన్స్. Governance of higher education institutions by independent boards having academic and administrative autonomy, light but tight regulation by a single regulator for higher education, increased access, equity and inclusion. So the institutional restructuring and consolidation, let us see this one also. By 2040, all higher education institutions shall aim to become multidisciplinary institutions, each of which will aim to have 3,000 or more students. So on all these institutions now, which are, whether it is a technical institute, not a technical institute, they are going to be made as multidisciplinary education institute. That means they offer all the courses. They offer agricultural courses, they offer general degree courses, and also they offer engineering courses also. There shall by 2030 be at least one large multidisciplinary higher education institute in every district. So the plan is to locate in every district a higher education institute by 2030. The aim will to increase gross enrollment ratio 50%, as I told. లెటర్ అక్కడ ఉంది, అది తీసుకెళ్ళి రిషారాణి గారికి ఇచ్చేయండి. 50% by 2035. The aim will to increase, as I told. So the aim is to increase the 50%. Now the gross enrollment ratio is 26.3%. Growth will be in both public and private institutes, with a strong emphasis on developing a large number of outstanding public institutes. A university will mean a multidisciplinary institute of higher learning that offers undergraduate and graduate programs with high quality teaching, research, and community engagement. The definition of the university will thus allow a spectrum of institutions that range from those that place equal emphasis on teaching and research. That means research intensive universities. Research must be given more importance rather than the undergraduate courses. Those that place greater emphasis on teaching but still conduct significant research. Teaching intensive universities. Autonomous degree granting college will refer to a large multidisciplinary that grants undergraduate degrees and is primarily focused on undergraduate teaching, though it would not be restricted to that. So most of the focus in our research in the universities. A stage-wise mechanism for granting graded autonomy to colleges. Not only university, colleges also, almost all the colleges will be allotted autonomy in the coming years. Higher education institute will have the autonomy and freedom to move gradually from one category to another category based upon their plans, their actions, and their investment. Three broad types of institutions are not in any natural way a rigid exclusionary categorization, but are along a continuum. Higher education will support other institutions also in their development, community engagement, service contribution in various fields of practice. Institutions will have the option to run ODL also, open distance learning, and online programs also, so to encourage the gross emolument ratio and also for employees, provided they are accredited to so. So if an institution is NAAC accredited and it gets the A++, then it can start its own open distance learning programs. I think some of the institutions now in AP also, deemed university also, got A++ and they are also running distance learning programs also. Single stream higher education institutions will be phased out over time and all will move towards becoming vibrant multidisciplinary institutions or parts of vibrant multidisciplinary higher education clusters. This is another drastic change, making higher education institutes as a cluster. The system of affiliated colleges will be gradually phased out over a period of 15 years through a system of graded autonomy. So all the colleges will become autonomous colleges. So in the coming years, in coming 15 years, there will be no affiliated college which are governed by some universities. No college will be governed by university. Every college will become autonomous college. The overall higher education sector will aim to an integrated higher education system, including professional and vocational education. So more emphasis will be given to the professional and vocational education. The present complex nomenclature of higher education in the country, such as deemed to be university, affiliating university, affiliating technical university, unitary university, shall be replaced by simply by university on fulfilling the criteria as per norms. So there are no different types of these universities. So in coming years, there will be only universities. A holistic and multidisciplinary education would aim to develop all capacity of human beings, intellectual, aesthetic, social, physical, emotional, and moral in an integrated manner. Such a holistic education shall be in the long term the approach of all undergraduate programs, including those in professional, technical, and vocational discipline. Even engineering institutions, such as IITs, will move towards more holistic multidisciplinary education with more arts and humanities. Already, all of you know, in IITs, they are running MBA courses, some MSc courses also, MSc Mathematics, MSc Computer Science like that, and MBA also. Now, IIT is also encouraged to start the courses in the arts and humanities also. So students of arts and humanities also, they can acquire the degrees from the primary institutions. Imaginative and flexible curricular structures will enable creative combinations of disciplines for study and would offer multiple entry and exit points. Departments in languages, literature, music, philosophy, art, dance, theater, education, mathematics, statistics, etc. will be established in all the universities and they will be strengthened. At present, the education system was unbalanced. All the students are running behind either medicine or engineering courses only. No student is going to learn some sociology or economics or some philosophy or music or something. So today the courses are only job oriented. The students are running behind the job oriented. So the society has become unbalanced. And all these courses also, they are needed for the society. Sociology is very, very needed. Economics is needed. Sports is also needed. Today, see, we got only 7 Olympic medals. From 1896 to till date, that means over a period of 110 years or 100 years. 100 years. Sir, namaste, sir. Sir, చెప్పండి సార్. లేదు సార్, ఏం లేదు సార్. ఇవ్వలేదు సార్, టెండర్ ఇవ్వలేదు. ఇవ్వలేదు సార్, ఎవరికి ఇవ్వలేదు. లేదు సార్, అసలు అది అబద్ధం, తెలియకలేదు. వాస్తవం ఎవరికి ఇవ్వలేదు. ఎలమెంట్స్ అనేది అసలు తీసుకోలేదు. అది మాత్రం 100% చూస్తాను. లేదు సార్, అసలు అది అప్సెట్ సార్, అది పుకారు తప్పితే నేను చెప్తున్నా అసలు ఎవరికి ఇవ్వలేదు సార్. అయితే నేను ఒకసారి కనుక్కొని మీకు వస్తారు చెప్తాను సార్. నాకు తెలిసినంత మాత్రం ఇవ్వలేదు సార్. కనుక్కోండి. Sorry for disturbance. As I am principal, some calls will be coming to attend, so please bear them. So, education, mathematics, statistics, pure applied, social, sports, translation, interpretation will be established and strengthened at all higher education. So, curricula of higher education shall include credit-based courses and projects in the area of community engagement and service, environment education, and value-based education. The undergrad degree will be of either 3 to 4 year duration with multiple exit options within this period, with appropriate certifications, a certificate after completing 1 year in discipline or field including vocational and professional areas, or diploma after 2 years. This is one of the best option in the NEP. The degree is for 4 years. 4-year degree is a honors degree. If the students complete 1 year, he will be given certificate program. He will be given a certificate, a diploma certificate. If he completes 2 years, a PG diploma. If he completes 3 years, bachelor's degree. And if 4 years, it is honors degree. So this is very, very flexible degree program so that the students can discontinue if he needs a job or something. An academic bank of credit shall be established which would digitally store the academic credits. So this is also another drastic step. Whatever the course, wherever you learn, you can learn the courses and you can deposit your credits into the academic bank of credit. Academic bank of credit. These academic bank of credit can be carried over to other institutions within the country or outside the country. They may be valid anywhere and you can continue the further studies. So if you study some up to intermediate, you can deposit the academic credits. If you have any personal problem, you can discontinue that one. Again, you can go somewhere, you can use those credits and you can continue your degree. So this is very, very another major change going to come in the national education policy, that is academic bank of credit. The 4-year program may also lead to a degree with research. So this is also another new innovation. A 4-year degree, honors degree with research also coming. Students who are very, very interested in doing rigorous research projects, they may be used. Model public universities for holistic and multidisciplinary education on par with IITs, IM, and also multidisciplinary education research university will be set up. Higher educations will focus on research and innovation by setting up incubation centers, technology, development centers in frontier areas of research greater industry. Academic linkages and interdisciplinary research, including humanities and social sciences research. So, major focusing in the this national education policy is on vocational education. Vocational education. As I told, most of the students who are passing intermediate education, everybody is going to achieve bachelor's degree and they are asking a job. As I told, in China, 2.91 crore students are seeking for higher education, whereas in India it is 2.67 crores, which are interested to go for undergraduate program. But China, what it is doing is, it is developing the small-scale industries, and it is giving training in the vocational education, and it is diverting all the students to small-scale industries. Therefore, the pressure on the undergraduate education is going to reduce. But unfortunately, this type of arrangement is not in our, this one is not in our Indian education system. Everybody is going to achieve undergraduate and next postgraduate. Postgraduate also, the total population which are going for postgraduation is 27 lakhs every year, 27 lakhs. Whereas in China, only 12 lakhs are going for post-graduation. So a high pressure is there on the graduation and post-graduation. To reduce that one, NEP is proposing to give more emphasis on vocational education. By 2025, at least 50% of learners through the school and higher education system shall have exposure to vocational education, for which a clear action plan with the targets and timelines will be developed. Higher education institutions will offer vocational education either on their own in partnership with industry and NGOs. Bachelor of Vocational degrees introduced in 2013 will continue to exist, but vocational courses will also be available to students enroll in all other bachelor's degree programs, including the 4-year multidisciplinary programs. So a student can continue his formal degree and also he can continue this vocational degree also, so that he will definitely get a job when he walks out from the university or college. Lok Vidya, this is an important vocational knowledge developed in India, will be made accessible to students through integration into vocational education courses. The possibility of offering vocational courses through ODL, distance learning mode, will also be going to be explored. Minister of Higher Education will constitute a national committee for integration of vocational education consisting of experts in vocational education and representatives from across ministries in collaboration with industry to oversee this effort. Incubation centers will be set up in higher education institutions in partnership with industry. Already it was started, it was establishing some incubation centers in some universities also. In AP, there is incubation center at Padmavati Mahila University and also Sri Krishnadevara University. Atal Tinkering Labs, they are starting the Atal Tinkering Labs and Atal Labs also, Atal Incubation Centers also. So Indian standards will be aligned with international standard classification of occupations maintained by International Labour Organization. The credit-based framework also facilitates mobility across general and vocational education. So how to improve the quality of the research in all fields through a new research foundation? Already I told that new research foundation is going to be established in the country. So the main aim of that one is to integrate all the research funding agencies and to so that to remove the redundancy in funding. So establishing a national research foundation, the overarching goal of NRF will be enable to culture of research to promote through our universities. NRF will be governed independently of the government by a rotating board of governors consisting of very best researchers and innovators across the fields. The primary activities of the NRF will be to fund competitive, peer-reviewed grant proposals of all types across all disciplines, and also seed, grow, and facilitate research at academic institutes, and to act as a liaison between researchers and relevant branches of governments as well as industry, so as to allow breakthroughs to be optimally brought into policy, recognizing outstanding research and progress. And also, it is emphasizing the transforming the regulatory system of higher education also. So, regulatory system of higher education will ensure that distinct functions of regulation, accreditation, and academic standard setting will be performed by distinct, independent, and empowered bodies. These four structures will be set up as four independent verticals with one umbrella institution, the Higher Education Commission of India. The first vertical is Higher Education Commission of India, will be the National Higher Education Regulatory Council. So until now we have AICT, some Council of Pharmacy, Council of Architecture, UGC, etc. Regulatory bodies are there. Now they are all going to merge together and it may be called as Higher Education Commission of India. Higher Education Commission of India. Under that, there are four vertical organizations will be there. The first one will be a National Higher Education Regulatory Council, which will function as the common single point regulatory for the higher education sector, including teacher education and excluding medical and legal education. And the second one is National Accreditation Council, which is going to accredit all the institutions. Accreditation of institutions will be based primarily on basic norms, public self-disclosure, good governance, and will be carried out by the independent ecosystem. And the third vertical is the Higher Education Grants Council. It is mainly for funding and financing of higher education based on transparent criteria. And the fourth vertical is General Education Council, which will frame expected learning outcomes for higher education programs, also referred to as graduate attributes. A national higher education quality framework will be formulated by this General Education Council. The funding of all independent verticals of regulation, accreditation, NAC, funding HEGC, and academic standard setting, GEC, and the overarching autonomous umbrella body, HEC itself, will be based on transparent public disclosure and use technology extensively to reduce human interface. So as I told, all these are going to combine, and only one regulation commission, HECA, is going to act from now onwards. And the professional councils such as ICER, Indian Council of Agri Research, Veterinary Council, teacher education, architecture, vocational, etc. will act as professional standard setting bodies. The separation of functions would mean that each vertical within Higher Education Council of India will take on a new single role which is relevant, meaningful, and important in the new education system. And coming to professional education, standalone agriculture universities, legal universities, health universities, in other fields shall aim to become multidisciplinary institutions. So from here onward, there is no a particular technical university or a medical university or a health university. They are all going to combine into a multidisciplinary university. All institutions offering either professional or general education will aim to organically evolve into institutions offering both seamlessly and an integrated manner by 2030. Both capacity and quality of agriculture and elite disciplines must be improved in order to increase agricultural productivity through better skilled graduates and technicians, innovative research, and market-based extension. Institutions offering agriculture education must be benefit the local community directly. One approach could be set up agriculture technical parks to promote technology incubation and dissemination. Legal education needs to be competitively globally, adopting best practices and embracing new technologies for wider access to and timely delivery of justice. Healthcare education needs to be envisioned so that duration structure and designing of the educational program need to match the role of requirements that graduates will help. So given the people exercise pluralistic choices in healthcare, our healthcare education system must be integrative, meaning thereby that all students of allopathy medical education must have a basic understanding of Ayurveda, yoga, naturopathy. So that means the student must have, medical student must have at least basic knowledge of all these things, at least to differentiate whether it is a neuropathy, naturopathy, or a yoga or something. So there shall be a much greater emphasis on preventive health care and community medicine in all forms of health education. Technical education will also aim to offer within multidisciplinary education institutions and programs and have a renewed focus on opportunities to engage deeply with other disciplines. India must also take the lead in preparing professionals in cutting-edge areas that are fast growing prominence, such as artificial intelligence, 3D machining, big data, machine learning, genomics, biotechnology, nanotechnology, neuroscience, etc., which are used to enhance the employability of students. So this is all about some summary about higher education. And coming to school education, until now, the school education is 10+2. That was changed to some 3+5+4, some model. That means in government schools also, they are going to start nursery, play schools, LKG and UKG. Until now, there are no LKG, UKG, and nursery. They are all in private. They are only in private sector. Now in government sector also, according to NEP, they are going to change. They are going to change. So it is also very, very good this one policy where the poor students can go to government schools also from nursery onwards. That's why only Anganwadi, this one employees Anganwadi, they are going to give training for Anganwadi workers to how to cope up with the small children. This is one of the change in the school education. From the 6th class onwards only in school education, vocational training is also going to be start. So students from the school level from the school level, they are going to give vocational education. This is also another drastic step. So that students will have a technical knowledge also, and they are also skilled by, when they are coming out of the school only, they will also be skilled. So until now, the universities or colleges are awarding just only degrees, but the students are lagging behind these skills. According to a survey every year 15 lakhs engineering students are coming out of the colleges throughout the India. Among the 15 lakhs, only around 2 lakhs students are getting jobs and 1 lakh students are going to higher education. Remaining around 11 lakh students are on the roads only. This is only due to, there are jobs in the country, there are jobs in the private sector and also public sector. Only problem is the students does not have skills. So to improve the skills, to improve the life skills also, major thrust in NAP is about the life skills also, like sports, communication skills, life skills. They are giving the more emphasis. They are going to offer even like sports subjects also to take up by the engineering graduates, both in major degrees and also minor degrees. Until today, we are taking electives or minor degrees or major degrees, some advanced subjects like cloud computing or IoT or big data. Here onwards, students can take NCC, sports subjects also, so that students' skills also will be improved, both not only technical skills but also life skills also. So these are the some of the major changes made in the new education policy. So many changes are there. Many changes are there. Many these one are certain. If the all the policy, the whatever the policy was going to recommend for the government, if they are all implemented within the coming 10 years, then definitely the face of the our Indian education system is going to be changed, definitely changed. All of you know, in 1980, both China and India are at the same position, especially in education system. Especially in education system, both China and India are at the same position. But when by 2020, China is far away from us. It is competing with the USA. So among 200 best universities all over the world, if you see the rankings by Times or QS, whatever may be the international rankings, in international rankings, there are no 1 or 2 institutions also from our country. But that now the China universities, more than 10 universities are in among 200 best universities in the world. So China has drastically improved its education system regarding funding and establishing the universities, establishing the colleges, establishing the standards also. But until now, we are lagging behind in all issues. Still, we have only 900 universities with private universities, also both government and private universities in our country, which are not sufficient for our population. So there is a need of improving the universities also. And also not only improving the universities, there is a need of improving the standards in teaching and learning process also. So the corona has entirely changed the face of the teaching and learning process of the education system. Now the teacher has become a facilitator. Teacher is not a teacher now. A teacher has become a facilitator and a student has become a customer. I can say that there are 4 phases of education system. Education system 1.0, education system 2.0, education system 3.0, and now we are in education system 4.0. In education system 1.0, long back ago, during the rule of kings, at that time Gurukulas will be there, Gurukulas are there. The students will go to Gurukula and they will do service to the gurus, and the gurus will give the knowledge to the students. There are no textbooks, there are no examination, nothing is there. Gurus are going to preach the lessons in the form of mantras or etc. to the students. Even the student is a son of king, he must go to Gurukula only. He must eat whatever the guru gives the food. He must sleep on the sir, namaste, sir. ఎవరు సార్ ఆయన వీనికి లెటర్ ఇచ్చి 3 రోజులు 4 రోజులు అయింది సార్ మన నీరు గారు పని సార్ లర్నింగ్ నాకు చెప్పారు నిన్న మీటింగ్ ఏంటి సార్ జరుగుతున్నారు ఆయన ఫోన్ చేసి అయితే నేను హీరింగ్ గారితో మాట్లాడతాను So that is 1.0. And coming to education system 2.0, education system 2.0, under the British rule, Britishers introduced the textbooks and homework, etc., etc., and they forced to study the material in the textbooks. That is the foundation of mugging and rote learning. From the British period only, the students came to mug the textbooks and rote learning was started. That is 2.0. Britishers only introduced the education system in English language, not in local languages. And also they have only given the subjects which are useful for to make the clerks. And coming to the education system 3.0, entire education system, almost 60% of the education system was gone into the hands of private management. Private sector is now dominating the education system. And coming to 4.0, in the corona scenario, total education system has become online education system. In the online education system, teacher completely lost his existence. He just become a facilitator, just providing a link like this and placing before you. And student has become a customer. So in this scenario, students, faculty must be very careful, lecturers must be very careful to improve their technology, to improve their skills, and to protect their existence in this scenario. So this is all about higher education system. So thank you once again, the management of KLC, for giving this opportunity. Thank you. సార్ ఇవ్వలేదు సార్ వీసీ గారిని అడిగాను ఇవ్వలేదు సార్ ఏమి ఇవ్వలేదు ఒక్కరే సార్ ఎవరు సార్ అది అసలు వాళ్ళు ఎవరు చెప్పమని చెప్పారు సార్ నేను ఇప్పుడు వీసీ గారిని అడిగి మీకు చెప్తాను యూ హ్యావ్ ఎనీ డౌట్స్ యూ కెన్ ఆస్క్ If there are no doubts, anything, I will leave. Okay. May I leave the session?
Sir, on behalf of participants and KLU team, myself, Naveen Kumar, I want to give an immense pleasure to deliver the vote of thanks to you. As I I would like to thank you once again, sir, because you have given very interesting, inspirational thoughts. Many students have been inspired with these things. Through your excellent presentation skills, sir, we all are now have we all have understood what is the actual scenario of the national education policy. From all, sir, on behalf of all people, I heartily wish to you, sir. In future, we all want such type of knowledge from people like you, sir.
Thank you.
Thank you, sir. So participants, again, the next session will resume from 3:30. by God grace, Participants, good afternoon. Again, we are going to deep dive into the world of VPC pairing. Okay, that will be demonstrated by our Stephen Samuel sir again. So, participants, it's our request. Be ready. All the systems and settings. Okay, Samuel sir. Samuel sir. Samuel sir. Samuel sir. Am I audible to you, sir?
Okay, I can hear you. I can speak now. Yeah.
Okay, sir. Okay, sir. So you
All right.
can address this gatherings.
Sure. So welcome back. I will share my screen. Okay, so we were setting up our two-tier. We were setting up a two-tier web application. We were onto that, so we done quite a bit so far. Okay, so we can continue with that. There's something I need you all to do first. You see, it's something like this. After we set up everything, there's it's a process that we have to go for. So basically what we've been doing so far, we set up our VPC. Let's go there first. Okay, so we have our VPC in place, our two-tier VPC. Now, after that, we needed to set up our network, of course. So we had to set up separate subnets. So that's what we went through. We set up two. We set up our two-tier database subnet. I mean, that's the name, two-tier database subnet. And so we have to actually create separate subnets for our application and our database layer. Our application layer has to be reachable from the internet. We don't want to expose our database to the internet. Fine. So we created that. Then we, okay, and we have our application subnet over here. We created them with different availability zones. For the application subnet, we just have one availability zone. That's fine. Our database subnet has two availability zones, and we put in the CIDR. This is for our application. And our database, we have so this is subnet 1. We have two. So all of they're both basically the same. There's no public IP address over here, as you can see. Okay, then we set up our route tables. We have one for both the database subnets. So both the database subnets share one route table. Here are subnet associations. We have another route table for our application. So this is the route table for our application subnet. We added this to for our internet gateway, which we created later and then added it. So this is up till here. We should be straight. Okay, along with our CIDR. Then after that, we created our internet gateway, and this is what's needed by our application subnet. So this is our internet gateway. Very straightforward to actually create that. Okay, it's been attached to our, and we attached it to our VPC ID. We came back to our application database. We should have a route added to our application route table with a destination as this. This means all access. I mean every all access. And targeting the internet gateway, which is like this. Now, something I need you all to do. After this, we need to do some, we have to set up a security group and a NACL. That is, NACL is our network access control list. So that is a bit like traditional firewalls. But the security group is also very similar to our NACL, but that's for instances only. So we are dealing over the network. We have to set stuff up properly. Over here, we'll create a new network ACL for our application subnet, and we'll associate it with our virtual private cloud. But there is something we'll be taking in a database also, an RDS. Okay. Now to actually access it, we have to the instance which contains that, not the database as such, but we're going to create a new instance which will be of another, not what we had normally create, and then we start. It's a Windows server instance. Now to actually connect to it, we need this remote desktop client. So you can, let's just go ahead and do this. So this should be it, our Windows desktop client. So we can download it from here. I've already downloaded it, but I'm having a little bit of difficulty actually logging in. Anyway, just click on this and choose your client, probably Windows 64. All right, and then sign into it. Well, yeah, just sign into it. So just go ahead with that now. Yeah, just Google this remote desktop client and then look for remote desktop client. We are going to RDP into our instance. And what we have to need to do, we're going to set up a, firstly, we have to set up an actual server. So we set up IIS, but first we have to actually connect to it. So we need to set this up because it's not the same kind of connection that we did with our client, other clients, other instances. It's not like that. Over there, we use a SSH client. Over here, we're using an RDP client. So we have to connect using this Windows desktop client. Okay. So just go ahead, everyone, and get started with this. You'll get, it'll download a MSI file. And once you have the MSI file, just click through it. Okay. And install it. Then try to log in. Now you need some kind of, I do have a Windows Live account. But for some reason, I can never ever log in properly on this to Windows. It always can never recognize my account, or after changing the password also, it doesn't know what's going on. It's really. Anyway, once it actually starts up, once it launches, you'll get this page. Maybe I'll just create another account. Okay, forget it. I'll fix it later. There's other ways to connect. What we need this for is actually to connect to our client. So we need that. That's the reason we need this a remote desktop client. But then all this stupidity about subscribing and signing in and all that. And then you cannot find your stuff when it's needed. Okay, so where were we? So we were over here. We've done all this. We've done all this basic setup. So we got an internet gateway in place. The next thing we need to do is we have to lock down our subnets over a little bit over here, right? So by using the network access control list. So in our virtual private cloud, this console, come down and look for your network ACL. It should be around here. Here we are, and it's under security. So click on that. Network ACL. So these, as you can see, let's see, these are default. They come, you don't need to worry about it. In any case, we're in the habit of putting tags. Otherwise, you'll never find anything. So that's a good habit to tag everything that you're creating, right? Okay, so these are your we haven't created this as yet, right? Naveen, are you there? Hello? Naveen, you're there? Because I don't think we created this as yet. We need to. I just we don't want too many NACLs.
Yes, sir.
So we haven't created this as yet, right?
Yes, sir. Yes, sir. Well,
Huh? Okay, okay. Then let's go ahead and do this. Okay, so just click on create network ACL. So what we are going to do is we'll create a new network ACL for the application subnet first. Of course, we have to associate that then with our virtual private cloud. Then we'll create one for our database NACL. So that is basically, we are working on our network infrastructure now. So we can put it as So NACL, and then we'll need one for our application. Okay. So that is easy enough to recognize, I guess. We can't have too many. It'll conflict some stuff. We have to be careful with that. Then, of course, our VPC is over here. And yeah, that's basically it. Okay. So now we can go ahead and create our first network ACL. We've associated it with our VPC. Let's just take a look. VPC ID is over there. Great. Now we need to associate. Let's do it right now before we move on. So we have to associate it with the application subnet. And then see what it actually does. So we come down here. You saw what I did. I went to edit Subnet Associations, and I've done this. Okay. So now I can save the changes. There. So this is a network ACL. So by default, it will deny all traffic. It blocks all traffic that is coming in and going out. So we can't actually have this. Nothing will get done. So we have to add a rule to allow all traffic from out of our database. Our application is fine. This is for our application, right? So it's fine. So the destination can be realistically anything. So okay, we can an outbound rules we can see same thing. Okay. Okay, we can edit our outbound rules. We can add a new rule over here. Actually, the rule number is normally in about 2-3 digits. But in our case, we'll just now come over here and click on all traffic. The destination is fine. Okay. And as you can see over here, rules are evaluated starting with the lowest numbered rule. So as soon as the rule matches traffic, so when you're doing your rules, you have to actually see what's your priority. As soon as the rule matches traffic, it's applied, regardless of any higher numbered rule that might contradict it. So this is, let's take the lowest number as fine. But generally speaking, it's like in a couple of digits or 3 digits. Anyway, it's not a big deal. Now, the outbound restrictions, okay, that's fine. We've removed the outbound restrictions. Now, our inbound rules. They denied all traffic, period. No questions asked. Okay, so now let us edit it, but we'll allow inbound traffic to ports, firstly our HTTP, then our secure port, which is 443. And there's another one, which is for RDP, our database port. So, you know how every database has its own favorite port. What is it for MySQL? I think it's 3306 and all that. It comes like sort of pre-configured nearly. Anyway, let us just add a new rule. Okay. We can't actually even remove this. It's, you can see. So the only thing we can do is we have to add a new rule. Keep this as something like 401 and come over here as select all traffic. Now that would be, we have to match up our CIDR. So that should be 10.0.2 0 slash 24. 10.0.2.0 slash 24. Add another rule. 400 say. This will also be all traffic. Okay. So that'll be 10.0.1.0. Oh, it should never ever be like this. It should be 0.1.0. 10.0.1.24. Okay. As we discussed about CIDRs yesterday. So that is okay. That's fine. Now let us add our for HTTP. Oh, okay, we're going in order. We'll do HTTPS then. Let's search for HTTPS, HTTP. Okay, 443, right? You can see it automatically picks up the port range and all that. And for this is fine. HTTPS, yeah, that's fine. This is allowed from this source, and here's a port range. That's okay. That's also fine. One more now we have to do for, oh, that can't be 400. That should be 200. And this will be as a normal HTTP. That will be on 80. This will also be the same. Okay. And now finally we need one for our database. This can be 100. So you see the numbering, how it's coming in. I'm putting one of the lowest numbers for our DP. So like we were discussing, the lower numbers get the highest priority. So just go look for RD and here's P3389, as you can see. Now RDP 3389, that's our port range, and the source will be 0000. That's okay. That's fine. So far, so good. Now we can okay. So that's done for our application. All right. This is all our application. So this is our network ACL. We are actually setting up our network in that way. So NACL application. Fine. All right. Now we do one for our database. NACL. Set our VPC. Create a network ACL. And here's our network database. NACL database. Okay. So what we are going to do is we allow for all traffic on all ports with the application subnet to flow. But everything else is denied. Okay. You understand why also, because we are willing to accept traffic only from our application. As a matter of fact, in a real production system is much more restrictive, or it should be. So all traffic on all ports with the application subnet is allowed to flow, but everything else will be denied. So let us do that. So let us then edit our inbound rules. Here's our inbound rules, which just actually denies everything. So let's edit our inbound rules. Nothing much we can do over here. We can't even change it as we saw before. So for our inbound rule, we are here. We just keep this as 100. And we are going to put all traffic. This will be like this. 10.0.0.0.24. And that's that. So these are inbound rules for our database. So inbound, we are at the moment, what we've done, we've allowed actually all traffic and from this particular source. So everything from our application subnet is allowed in. Okay, so far so good. So now we can go ahead and do our database. I mean, we are already on a database. Inbound rules, let's check. Okay, so far so good. Here's our outbound rules. And what is it? As you can see, deny. So this is actually a little simpler, setting this up. Specify your rule number, and this will be all traffic. That will actually flow out as long as the destination is like this, it's allowed. Okay, so as long as it's going to the application, it is allowed out from our database. So this is important, otherwise, so don't make a mistake here, or it'll never reach, it'll get lost in the traffic, internet traffic. So we can save that. So now we have actually set up our network. We've locked down our subnets with our network access control list. So, all right. So we'll have to go and we'll create a security group that is also necessary. It's not that much. It's basically we have to allow access on because it applies to our instance. Our security group is actually going to applying to our instance. Anyway, before we actually get into that, we've got a network infrastructure. Now we can set up an EC2 instance to run a web application. However, before we set up a EC2 instance, we need to create something called a network interface. Now in AWS, our network interface is like a virtual network that we attach to our virtual private cloud. And we will assign it to our EC2 instance. All right. Okay. So we will need to go down to our EC2 dashboard. Okay. Now what we are going to do, come down over here, go to the network interfaces, click on it. And here we have a create network interface. So our network interface can simply be we are actually going to hook this up to our application. We can just call it something like app-ni. Now our subnet, choose the application subnet. Two-tier database subnet. Excuse me. Two-tier application subnet. Two-tier application. Okay, this is it. Everything else, all this, I guess we can leave as default. That's fine. That should be fine. All right, now we can set up a this is also okay. By default, it allows access on the default VPC security group allows access on the HTTP port. So this should be also be okay. Okay, now we can create our network interface. Now under security, we come and we'll need to actually create a security group. So that's going to be used for the application. So let's go ahead, create a security group. And okay, now let us set up our rules over here. So we need firstly HTTP, of course. So let's take HTTP. That'll be 80. Source will be custom. This will be like 0.0.0. Take the first one. Take another one for HTTPS. Okay, and then this will also be the same. It should take this. Okay, that's also fine and good enough. Take another one, put it as all traffic. This will be 10.0.0 12.0. It's come up already. It knows already what we need to do. I think that should be it. Let's take a quick look. Here's our HTTP setup. Our inbound rules, our outbound rules are. Oh, we forgot our outbound rules. Have we? No, okay, that's fine. I'm actually just wondering whether we need for the inbound from the RDP over here. I'm actually. Just a sec. Our inbound rules are absolutely necessary. I'm just thinking about our outbound. So basically, all communication within our virtual private cloud is permitted. That is fine. Inbound traffic is okay.
Even sir,
Yeah,
sir, I think this outbound rule is all to all, will allow all to all
it
communication.
is. Yeah, exactly. No, return traffic is allowed. Actually, security groups are they're stateful.
Yes. Yes.
No, it's okay. Outbound rules are fine. Regardless,
Anything, what
yeah,
we should,
it can go out. It's actually going out.
yes.
So that is also fine. That is okay. So here's our security group, which we will, this security group is going to be used for the application. No, that is necessary. So that is necessary. Outbound rules, just keep it like that. All traffic. No big deal. That's fine. Let's create our security group. Now we can create a EC2 instance. So let us go to our dashboard. It is a bit of a different instance than what you're used to. Okay, so let us see. We launch our instance. Now we won't be taking this. Not for our 2-tier. We need something else. Of course, we need something that's within. Take this, what is over here. Just type this into your search. It's free tier eligible, don't worry. But just remember, I have to do the same thing. But whenever you're finished with your instances, your gateways, all your stuff, stop them, terminate it, delete them. You don't want to crawl over your free GB limit. And when you're setting up stuff, be careful that what you select, yet allow you to select anything, but select what is free tier eligible. All right. So everyone got that. It's on Microsoft Windows Server 2019 with base containers. Okay. Got it, everyone? So we can go ahead with this. We can select this. This you knew already what was coming. Actually, we do not like we have that many options. That's a free trial that's available. That's the only option actually. Good enough. We'll configure our instance details. Now we have to configure our instance details so that it is associated with our application subnet. So here we have this. All right, so we've got 2-tier application subnet. We've got our network, which will be our 2-tier virtual private cloud. This auto-assigned public IP is important. Otherwise, you'll never get any public IPs. We'll only get private. For instance, we'll never be able to connect to it also. You can't, very difficult. I mean, it says you have to configure this and that and the other. But without a public thing, we can't connect like how we normally connect using SSH. This time we're connecting via this RDP client. So that's why I need you all to have this in place. All right, now for the don't put this, put enable. Don't take the subnet setting. Just say enable so that we get our IPv6 addresses. IPv4 will be there and private, but we want IPv6 because we must connect. If you don't manage to connect, then we can't actually set up much over here. Okay. Let's just check everything. Network, subnet, public IP. All right. So now we have our network interface. A little bit different over here. Yeah. So I was wondering why it wasn't initially. I was wondering how come it's not letting me set up my network interface. Actually, it's pulled it already because the network interface is associated with your subnet 008 BCC. Okay. Your subnet over here is there, so the same. Yeah. APNIUSEC2. Just do that. Your network interface will automatically has to cover this subnet because your instance is tied to this subnet. What if not tied? Actually, part of it. Okay, tied. So the network interface that we had created was here. You can see here's our tag. Now we're in the habit of keeping stuff with tags. There's less chance of confusion as to what belongs where. So here's the app and I select that, make sure it's there. Otherwise, sometimes it assigns it automatically. You might also find that on your screen. And it'll be disabled. So don't worry about it. If it's a disabled, it's very often assigned directly. But okay. Primary IP will be auto assigned. Now this is the thing, IPv6 CIDR is it'll be okay. That's why what is here? Actually, we need a public IP. This is a little strange. Okay. This might be a problem later. Let's see. Okay, so now we have to fix that, might have to fix that later because we need to, we'll see. Okay, so this will be our name. A security group we have, a 2 tiers SG. So this is our security group. Seems all right. And we can review everything and launch. So we got a Microsoft Windows Server. Security group. Instance details. Just create a new key pair. That's okay. And we can launch our instances. This is where the tags were. I knew it. Forget it. We don't need the tags. So it'll take a little few minutes. You know, after the few minutes it takes. So once it'll take a few minutes to spin up. Then we can attempt to connect with it. So how strange, you never allowed me to give it a name. You see, how weird. So once this is done, oh, it's running already. Very good. That was very quick. So just come over here, right click this, and now you can say connect. So we connect a little bit differently. We need we got these options. So unless all this is set up, you're basically stuck with the RDP client. But normally there shouldn't be a problem. We can use any remote desktop client actually, or we can and then this is the RDP shortcut file. This is how it looks like. So the full address is, this will actually give you your IP. Okay. Now, once you connect, you also have to, this is your username. So when you use your remote desktop client, so today, please just set it up. We have to download the client and get it running. So what it going to happen is that, okay, you need to enter in your username and the password. And you store the password in a safe place. Now, okay, so watch this carefully. Yeah, just click on get password. Then you will have the, it already knows this is the key pair associated with this instance. So you simply browse to your key pair and to tier keypair.pem and open it. Okay, and it will come like that. You can do this now. This is just set up. You can do it straight away. Just come over here, browse to your key pair, and either you just browse, otherwise you can simply copy paste. This is your RSA. For me also, actually, I chose RSA. This is your private key. So this is very important. Without this password, we can't log in at all. We won't be able to log in on the remote desktop client. Okay, so go ahead, just get this done. Right. Okay, so everyone's over here, I guess. So now we'll go ahead and we'll decrypt the password. And this is your password. So I suggest that we simply take a new one. We need all this information to connect. So just copy. Let's see if it copies properly. So we need the IP address. The username will be administered. The password will be this. So after this, hopefully it will be a simple thing to actually log in. All right. To actually log in with this. We get our remote desktop running and then we log in with this. Now, once we get that running, once we get that, then we will go inside. This is basically we are connecting to our Windows server. Okay. So just a quick overview of what we'll do to finish this off. We're nearly done. We're nearly done. About 80% of the way, actually, we are done. So we'll can't finish it today, but that's okay. We'll finish it tomorrow morning. What we will do, now we have all our information that we need. We will RDP into our instance. Okay. And then we will set up a Windows IIS server. We still haven't got to our databases yet. For getting there. Okay. I just giving you an idea of like what steps we have to take. It's a process. All right, so we will log in, we will RDP it to IIS. We set up IIS, and now inside that, you all are familiar with this. There's a roles and features wizard. We will simply select it. It's not a big deal. We'll simply select it and we'll select IIS server. All right. Once you are done that, and once that is set up on our instance, then we can connect to our instance from the internet. Okay, so we'll have our web server set up. Okay, and then we'll navigate to this to the browser with simply like how we normally connect. We'll do it that way. Only after that, once we got our web server in place, which is II Internet Information Server, then we can set up our database using Amazon's Relational Database Services, RDS. That's what we'll use. Now, this service will allow us to create Amazon managed instances of the most popular databases like Oracle. Well, it'll allow us to create it. Pricing, we have to see. Anyway, just to let you know, the most popular databases like PostgreSQL or SQL Server or whatever. So we'll create a SQL Server because you already have Windows, right? And Windows products work best with other Windows products. They're not very welcoming to outsiders. So we will set up a SQL Server. So in other words, we will create a SQL Server instance. And of course, we will need something called a DB subnet group. What this actually is like a database that we can associate with virtual private cloud because of its subnets. the subnets it contains. It will allow it to be associated with a virtual private cloud because of the subnets it contains. Okay. Okay, so now that okay, we got a few more subnets to create. We need to set up our IIS server. We need to connect to our instance, set up our IIS server. Then we need to actually set up our database. Okay. So we'll use SQL Server for that. Then after all that is set up, that's okay. We'll RDP back into our application server and we'll test our connection to the database. We can run a lot of commands from it, but for now at least we should, if we connect to it, then that's our job is done, right? So that's what is left for us to complete. So, okay, then, so I believe, so that's it for today then. Thank you very much for your time. And tomorrow we will also, we had a little discussion about, storage, like can we transfer files? We were looking at VPC peering where we can transfer files across virtual VPCs. But then of course that is using private IP addresses. Anyway, the way it's done is done via this storage. So you upload a file to say your S3 and then you can share it. It has to be done via your Amazon services because you are communicating not through the regular internet, but via an application, Amazon's global backbone. You don't even touch the internet at all.
Hello.
So tomorrow we will also do a dive into storage. So tomorrow I think is S3. We will work on all the different features and explore it in detail tomorrow. So thank you very much and have a nice evening. We will meet tomorrow morning.
Sir, it's me, Naveen. Thank you to you also
Yes,
because
Naveen, please.
I have not reached at this level even before. So thanks to you for your such things and from the department side and from the participant side, I would like to continue your at least one or two session more.
Yes,
It is
I
our
believe we
demand
have
because
till Saturday, as
yes, sir,
far as
yes,
I
sir.
know. Unless there's a
Thanks,
change
sir.
in the program, I
No, no, sir.
believe I have time with y'all till then. Until the schedule is changed otherwise.
Honestly,
You will let me know, I think.
uh, yes, sir. Yes, sir. I know. So honestly speaking, I we know we people knows something little bit, but have not drilled down at this level. So amazing.
Uh-huh. Uh-huh. That is
I,
no, we want to do actually every day I intended to do a deep dive into one service. So when you come out of it, you're very confident. So
yes,
the
sir.
first
Yes,
day,
sir.
as you saw, there was nothing. We did a lot of theory, but that was for your foundation. It was
Yes, sir.
necessary. But
No,
every
yes, sir.
day, I hope we will do a deep dive. We'll take one thing, like we
Yes,
did
sir.
EC2 one day, another day virtual private clouds. Today we did load balancers, and now
Sir,
we're
you
setting
are.
up a two-tier security architecture. So like that, every day we'll do a deep dive into one thing, one
Yes, sir.
service at least.
Yeah, definitely, sir. You are showing practical approach, but our mind will be swept into the conceptual approach.
No, that is good. Because your
Yes.
conceptual understanding must be there, otherwise you can't work with Amazon Web Services. Because so we have to understand conceptually how the Amazon, like the architecture we discuss, right?
Yes, sir.
And how things relate. Once you understand that, the basic Amazon architecture, which is a lot what we're discussing, how it's set up, then you can work with this very effectively. Otherwise, it'll be difficult.
Yes, sir.
you know, you make more mistakes. So you must, if you understand it, it'll be easier for you eventually.
I have come to know about this concept, sir, having watching this schedule right now. Otherwise, whatever
Good.
I know
I'm glad.
that.
I'm very glad about that. Really, I'm very glad. And we will do a lot more.
Yes, sir.
We'll do a lot more. By the end of this, you'll be pretty confident about working with many Amazon services. I'm sure. So anyway, thank you again. We shall meet tomorrow,
Yes,
right?
sure.
Okay. Thank you, Naveen. Thank you all.
Yes, sir. Thank you to you, sir. Again, to participants, we will meet again. Not we will. We are meeting again tomorrow from 9:15. So hope you will. Goodbye.